To get started, all that we're going to need is an empty project, preferably with no template and no starter content. As an example, what I have here is a brand new Unreal Engine 5 project. You can see there's nothing in here. Just to mention that everything I cover here will work in Unreal Engine 4 and Unreal Engine 5. To use the assets that I'll be sharing with you, you will need at least Unreal 4.26, but any version above that will work perfectly fine. To access the assets that I'll be using for all of the content in these videos, you can get that from the link in the description down below to the Devi assets on itch.io. There will be two options in there. One is a fully working project with some basic blueprint setups. I would recommend leaving that one for now. That one's just a very basic introduction to the Devi mascot. It won't have the kind of full-featured character controller that we'll be creating here. It's just a very basic example. The one that you want to download is the Devi assets only. That's going to provide a very basic template level, the animations, the mesh, and the very minimum requirements that we'll need to get this project going. So I'd recommend downloading that one. That will give you a project in 4.26, which is why, as I've mentioned, you need that version to be installed. But when you have that downloaded and opened, we are ready for the next step. The project you've just opened should look something like this. As I've mentioned, we have just a very, very basic level. This will be enough for us to test all of the movements though, a couple of walls to test our wall jumping, wall sliding, double jumping, and a floor to run around on. What we want to do is we're going to take all of the assets from this project. So that's going to be everything including the animations, the materials, meshes, and the map itself. Now, if you wanted, you can come in and just take individual assets from the project. So you can migrate just the static meshes or the skeletal meshes or just the animations. What I'd recommend is taking the entire bulk of this. So what we'll do is with both of the folders collapsed, I'm going to shift select the assets and the maps folder. With those selected, we can right click and we want to find the migrate option. And with migrate selected, this will just tell us a list of the things which are going to be exported to our other project. So that is all of the animations. This is really handy because this will keep a link to our skeletal meshes. We probably don't need the mask. I'm just going to untick the mask and it will bring everything including the maps as well. And if we scroll down, we can see that's taking the main map and the light build data and everything that I have here. So that all looks fine. We want to press OK. Then this next step is really important. You want to navigate to where you've stored your main project, so that new empty project. Mine is called third person in my Unreal Engine 4 projects folder. And then when we're inside of this, we want to go to our content folder specifically and double click into content. Now, when you're migrating anything inside of Unreal, it's really important that you choose the correct folder. If you put this anywhere else, you will be given a warning saying that some things may not come across correctly, or you may have some bad assets being exported. So make sure that you put this in the content folder. It's exactly where the migrate process is expecting to be directed. If you select that, what you should see is the content migration has completed successfully with no warning errors. Now, this will only work if you're exporting from a version lower or the same as the version you're working in. So this is a 4.26 project exporting assets to a Unreal Engine 5 project. What wouldn't work, you're more likely to come up against errors if you're exporting from a 4.26 project down to a 4.25 project. So just make sure that you have the right engine version installed, at least 4.26 or above. With that done, we're done with this temporary project, so we can now close this one down. And what we want to do is just double check that everything has come across to the new project correctly. So we have all of the animations. We can just open one of these and we'll see that we have the running animation set up as we want, all linked to the correct mesh. The material is already applied, so this is looking good. Now we can also go into our meshes folder just to check that we have everything here. So we have both versions, both of their physics assets and the skeleton, and then the map, just to double check that we have all of the map set up as we want. Okay, so that is all looking pretty good. Now, a few things stick out here. There are just a few kind of general house tidy or standard project setup steps that I take in any new project. The first thing is whenever I open a new window, I want it to be docked here. I'm just going to go to Edit, Editor Preferences, and then just drop down the Asset Editor Open location and change this from default to main. So default is this floating window, which we don't really want. And main now means that whenever we open something, whether that's a blueprint, a window from up here, or an asset, it's always going to dock it along this top window. So if we just check another mesh, that will now always open up here. The other thing is we don't want the auto exposure, which is going to be trying to correct the light balance when we're in the editor. I'm going to go to the project settings. I'm going to look for auto exposure. And we just want to untick the auto exposure. And I think even if we untick this in an Unreal Engine 5, we also need to set this to manual. Otherwise, it's going to still try and process some form of auto exposure in the background. That just means now that whatever we see here will be exactly the same as what we see when we press play. Now, the next thing that kind of highlights that we're possessing a default pawn in here because we haven't set any of the project defaults. So I'm going to go ahead and do that now as well. So we have basically all of the groundwork done by the end of this video. Now, what I'll do is I'm going to come into the content folder. We'll create a new folder here. So Control-Shift-N is a shortcut to create a new folder, and we'll call this one Blueprints. Inside of the Blueprints folder, I'm just going to right-click and create our first blueprint class. The first one we'll need is of type game mode, and I'll call this one BP_game mode base. Now that we have the default game mode ready for the project, we also want our default character. So we're going to right click, go to blueprint class, create a new character class, and call this one BP_player base. Then I can hear my fans ticking away quite heavily in the background. So in Unreal 5, what you might want to do outside of play is we can drop down this, and this will work in Unreal 4 as well. Untick real time, and this just means that nothing will be processing when we're not in play mode, and it just goes a little bit easier on the GPU and the processors. Now, even though I'm using Unreal 5 to try and keep this as relevant for as long as possible, my system does struggle a little bit with this, so I will be taking some useful steps to try and get the project working on lower spec systems as well, like my own. So what we're going to do next is, now that we have our blueprint classes ready, we're going to go into the project settings. We'll navigate to maps and modes, deselect the auto exposure if you still have that. I'm going to set the default game mode to the one that we've just created. And the default class, we want the default pawn to be replaced with BP_player base. That will also update this in the game mode if you haven't done that before. So we can check that in a second. And whilst we're here, we can change the editor startup map to our main one that we've imported. And if we wanted to ever build this, we'll play this in our main map as well. So that now means that whenever we come back into the editor, or if we give this to somebody else to play, we'll automatically be loaded into this test map that we have just here. If we were to press play now as well, we can see that the default game mode is our custom one, and the default player is also our custom character. Now, they won't do anything at the moment. We haven't set up any inputs or anything, but also just to confirm, if we go into the BP_game mode base, then what we can see is the default player class has been set to player base. So anything that you change here will be automatically synced with the game mode that you've selected here. Vice versa, if we were to change something here to just the default character and we compile this, go back to the project settings, we can see that we get the character as the default player. So just keep that in mind and make sure that you have the correct player class selected. Obviously, we're going to be building all of our logic into the BP_player base. So we'll keep that as the default, compile that, save those, and we now have the project set up and ready to go. So this is going to be the basic layout for our kind of game as we go through and trial things. And this just means that now, as soon as we start adding our features and updates to all of our classes, we know that we're ready to just press play and test out our new features. To get the very basics of our character moving, we're going to need to implement some input bindings, and we'll also need to begin getting the visuals set up for our player class. So we can go ahead and open the BP_player base. Now, what we can do here, first of all, is whilst we're in the class, we'll give this a skeletal mesh. So the mesh that we have here for the character base, all of the inherited components. So we'll be driving all of the collisions through the capsule component. This is referenced heavily in the character movement component. And if you wanted to know more about this, then you can go into the C++ side of things and see how this is set up. But we'll be covering the kind of theory behind how the character movement component is working as we go through the content. And this is really going to be the highlight of what we're looking at, as I think a lot of people try to use this, but don't fully understand how or what it's doing and how you can just get the best from this component. It's very, very powerful, very flexible, especially if you know how to use it. So what we're going to do for the visuals is we'll set our skeletal mesh to one of the Devi models here. Now, you'll have to ignore the colors and weird glowing effects that you'll see in my project. I don't believe this is an Unreal Engine 5 issue. I do have a somewhat faulty GPU apparently, so you might see some weird flashing and colors like this happening, you will just have to ignore that, unfortunately. Now, if we drag the mesh down to the bottom of the capsule, you'll see that this lines up pretty perfectly. I think regarding the scale, that should be about fine for now, and we can come back and test and update that as we go through and set up the movement. We're also going to want a camera to look through here. So we're going to add a new component onto the capsule component. We'll start by adding a spring arm component. And on the spring arm component, we'll add another component, which will be our camera. This just simply allows us to very easily set up the maximum length or distance we want the camera to be. We'll add some nice kind of polish effect through the spring arm a little bit later, which will allow us to easily add things like lag and other smoothing effects on the camera itself. And I think I'm just going to default the arm length to 600, and we'll come back and we'll change some values on this a little bit later. Now also we're going to test this for maybe a video or two without any animations. We're just going to make sure that we have this moving around properly and that we understand how that's happening. So next, over in the project settings, we want to, of course, add these input bindings to allow us to control and tell this character class when to move. So in the project settings, I'm going to go down to input. We will add a couple of axis mappings and some action mappings as well. So the actions are going to be nice and simple. We will need 3 of these. So that will be the first 3 action mappings that we'll need. The first one I will call jump. Then we're going to have one for sprinting, and we'll have one for walking. Okay, so we have the animations to account for all of these, so we can go into a few different types of movement speed and jumping. Then this is actually a button, so if we click on this, and I want to assign this to spacebar, we can see that automatically if we press the spacebar, we'll assign that to our input. Likewise, for the sprint, I'll set this to left shift, and the walk will be left control. If you wanted, you can come back in and add some gamepad inputs here, but I'm just going to focus on the mouse and keyboard. This will all be very transferable, and all you would need to do is add another input here, do the same thing again, and press the gamepad option that you want. Now, I've just dropped these down to keep things tidy. We're going to need several different axis mappings here. Now, these will control things like how much we're moving. So these are very, if you're not familiar with action mappings versus axis mappings, action mappings are binary. They're either on or off, touched or not touched, whereas axis mappings are constantly checking for a certain value. They can be a value between -1 to +1, including 0. So for example, an analog stick would be at -1 when you're pulling it all the way down and +1 when you're pushing it all the way forward. You could return something like 0.05 if you're only pushing it halfway forward. So that's how we get this kind of variable walking speed and things through gamepads, and that will be using something like an axis mapping. When it comes to keyboard, this is not exactly binary because like I've mentioned, we also have the state that it will be checking when you're releasing the key and it will still be returning a value here. And we can see the scale value that we're passing in. This will make a little bit more sense when we start using them if you haven't used these before. So what we want to do for the axis mappings, we control forward and backwards, left and right, all on a single axis mapping. So forward and backwards will be one mapping, left and right will be one mapping, and so on. So we'll call this one move forward. And basically the way that this will work is because we've named this the positive input will be forward, we'll first start by adding a new key here, which will be W for forward, and keep the scale to 1. We then want to account for that move backwards, which will be S. And what we want to change here is we're going to change the scale to be -1. So now whenever we press either of these buttons, if we press W, then we'll get a scale of 1 being returned. If we press S, then we'll get a scale of -1 being returned. And we'll see how this all kind of works into driving the direction that we're moving a little bit later. Likewise, we're going to add another axis mapping for moving right. We'll name this one move right. We'll click these buttons. So again, we'll assign 1 to D, 1 to A, and then for A, because we've called the movement move right, which will be the positive affirmation here, we're going to set A to be the negative, so we're going to set this one to -1. Then finally, we just need 2 more. This will be for the looking around, and again, this will be driven by the mouse this time. We'll call one of these look up, and the other one turn. This is going to control the camera as we move the mouse around. Now, we can't use the button click here because these are mouse movement trackings. We need to drop this down and we'll search for mouse Y for the look up input and mouse X for the turn input. The way that this works is basically up and down on the screen will be the Y axis, left and right is the X. So when the mouse is doing this, you're tracking either the Y movement or the X movement like so. We'll use this to drive the controller rotation for our character. And one other thing is I know that by default, +1 on the mouse X will actually be inverted when we plug this value into our character rotation. I'm just going to set this immediately to -1 to set this to look the correct way. If you do like the inverted camera controls, then of course you can leave that as +1 there. Returning back to the BP_player base, what we want to do is go to the event graph and we can start adding some of our implementation. Now, I like to keep this somewhat tidy by adding an entirely new graph just for our input. So I'll create a new graph here, call this one input. And that just means that anything that we create specific to responding to a key or button press can be tracked in here. If we focus on the simple things first of all, we can look for the move forward and move right axis bindings that we've just assigned. You get two options here. The first one is an event, which is what we want. We need the execution pin. The second is just the value which is being returned. So let's take a quick look at both, just so hopefully this makes sense if you haven't seen it before. So what we have here, we have the access value and the return value. These are both the same thing. And these are going to return different values based on whatever's being pressed here in the move forward. If we don't have either S or W pressed, then this will return 0. If you have W pressed, this will be 1. If you have S pressed, this will be -1. And again, they're both going to return the same thing. So if we just do a quick print string, just to demonstrate what this will look like. So you can see this is kind of like a tick event. This is going to run constantly. Even if you're not pressing anything, then you'll be getting 0. I'm now pressing W, returning 1, pressing S, returning -1. And like I said, if you had an analog stick, what you would do is you would come in here, you would add a new axis mapping. We'd assign this to the gamepad analog stick from the drop down here. We've got the thumbstick, and this would be the y-axis for forward and backwards on any kind of directional based movement. Like with the screen, we've got forward and backwards is Y. And what this would return is, again, if you held the thumbstick all the way down, that would be -1, all the way up would be 1, and anything in between would return a range between -1 and 1. So that's all this value is returning, and this is going to help us drive the direction that we want the player to move, whether that's in a positive direction across the world or negative. Then next we can get the move right function as well, or event binding. And what we want to do is, because we're in the character class, we have a whole system of pre-built movement functions that we can work from. And adding movement is as simple as calling the add movement input function. So this is going to be communicating with the character class and the details held within here. You can see that it mentions that if you're using a pawn, this won't automatically be applied, but in this class it will. All we need to do is provide a direction in which we want this to move and a scale at which to move across this direction. So the scale is just going to be our axis value, so either in a positive or negative direction. And the direction, so forward, if we think about the way that the Unreal is set up, forward is the red arrow here, which is the x-axis. So we want to move in either a positive or negative direction along the x-axis. So we want to say that for this version, we're going to provide a value of 1, which is indicating that this is the axis we want to move across, and these two will be ignored. If we press play and press W or S, we can see we do indeed move forward and backwards across that axis based on what we're passing in. So we're essentially multiplying this by 1, -1, or 0. And of course, if we're multiplying this by 0, then we're getting a 0 value returned and we're stopping the movement. Now, the other thing that I've noticed that a lot of new people will do is they will try and then come in and say, okay, I want my character to move faster. So let's say that was too slow, so we'll double the speed. They'll start plugging in values here, which is fine. That kind of makes sense, and I could see why. But you'll see that doesn't do anything. So then they'll try bigger and bigger values to try and get something moving in a faster speed across that axis. And again, you can see here it's not working. But what this is doing is it's basically saying if a value is plugged into the world direction, that is the one which will take priority, and you'll try moving in that direction based on the scale being passed in. Now, where the speed is actually coming from is the character movement component. So we've got these things here on the right-hand side, the maximum walk speed, the maximum crouch speed, and things like that. So what's actually being plugged in, and it's kind of being done almost in an invisible way in the background, I suppose, is this is actually accounting for the character movement component. It is moving in a positive value on the x-axis based on this scale value multiplied by the maximum walking speed. So if I turn this down to 200, what's actually going to happen now in the background is we're going to multiply 1 on the x-axis by 200 by the direction. So that means we're now going to be moving much, much slower on the x-axis there. So if you want to update the speed, you actually do it directly through the maximum walk speed here. If I increase that to something really big, then you'll see that we're going to pick up, after the acceleration, a lot more speed on that axis. So this is one of the first important things to get your head around with the character movement component, is this is only controlling the direction in line with the axis value for the scale. The actual movement speeds and everything are being done from the character movement. So the next thing is we can get some simple input on the y-axis. So we're going to do the same thing again. Of course, we don't want to move forward and backwards when we press left and right. So we're going to zero this back out and we'll set the y to be the positive one. So again, we'll press play and we can now move around in a somewhat kind of directional based way on the XY. And again, all of this is going to be calculated based on the character movement values. Now, this is very hard coded. This isn't going to be our final implementation, and you'll see why as we go through. But of course, you can probably already guess this is very much hard coded, that this is the exact direct world X and Y. When we go into the map, we're only ever going to be moving either in this direction or this direction, regardless of where we're facing. And we're going to want to take some of that into account a little bit later. Before doing that, though, we can set up our very simple looking bindings as well, which is going to be our turn and look up. And in exactly the same way, and for the same reasons, we're going to want our axis bindings, not just the axis values. So we get the events. And when we have those, we can move these into place. And again, you'll see these are exactly the same. Because they're axis values, we're getting the values returned. And what we want to do is directly update the controller yaw and the controller pitch, which is being controlled by the player controller or maintained and processed by the player controller. And we can do that with, again, a very simple function call. So for turning, we want to add controller yaw input. So this is going to update the yaw value being tracked in the player controller. And we don't even need to multiply this. We can just update it. So this is, as the name would indicate, an additive function here. So we're just taking what the current value is and applying the small value which is being processed here to that. And likewise, from the lookup, we want to get the add controller pitch. So pitch will be looking up and down, yaw is side to side, and then of course roll is something we don't want to do in this instance, but of course roll is the other one which is going this way, and of course we don't want to affect the roll because that would be a little bit strange. So now if we come in and press play, what we'll see is that we are rotated, but this is one thing that I really dislike seeing, and that is that the character is also being rotated around with them, which looks a little bit strange, especially if something's animating and you're in your idle pose, but you're kind of rotating on the spot. So we'll be fixing that a little bit later too. But the first thing is we're going to get our spring arm into position, because you can see that we could only move in one direction here. Because the spring arm has some settings on it, we cannot look up and down at the time. So quite simply, that's just because if we select the spring arm, we can see that we haven't told it to use the pawn control rotation, and it's the control rotations that we're updating here. So we're going to grab the spring arm, we'll tick this, we'll press play, and we can now see that regardless of where we've set the spring arm to look in the viewport, when we press play, this is going to be overridden by the values being processed here, so we can now look around properly. Now this is going to be the first problem. You can see that if I'm pressing forward, even when I'm moving around or looking around, I'm still only going in one direction, so it feels a little bit awkward to control and not really the best setup. To fix this problem, we can now do that because we're tracking the controller rotation properly. We can use this in a simple calculation to determine which direction we actually want to move. So what we want to do is we're going to get the control rotation. And for the control rotation, we want to break this down into a rotator. We only want one thing, which is the yaw, the Z value. So we'll break this. And we're going to make another rotator. So we'll pull from this and call the make rotator function. We're going to leave the roll in pitch as 0. So we're just going to plug the yaw into the yaw here. And what we want is we want to make sure that based on where we're looking, this always moves forward based on the camera's forward, not the world forward. And this always moves right based on the camera right, not the world right. So we've got two functions for this. The first one is going to be get forward vector. and we're going to pass in the forward vector from this rotation into the direction that we want to move. It's going to work out what values need to be plugged into the world direction. And from this, we're going to get the right vector. And of course, we're going to plug that into our right movement. Compile this and press play. And you can now see that depending on where you're looking, you will have your rotation set up, and the movement will follow the direction that your camera's going in. Just realized that the mouse is inverted in the wrong one. So what I wanted to do was invert my Y mouse axis. So if you're finding that it's a little bit awkward to control and it feels inverted, make sure that the up and down is inverted, not the side to side. Then when you press play, that should feel pretty normal to control. So we've got the movement working now. We can strafe based on where we're looking, and we can move forward and back, again, based on where we're looking, so that feels much better. That leaves us with this one problem, which is that the whole character is rotating with the camera. Ideally, we would have the camera panning around a stationary character. So we're going to fix that as well. Now, this problem is actually part of the character class, not the spring arm, like we've seen already. So what we want to do is grab this top root component just here of the class, and it's because of the class itself is set to follow the controller rotation yaw, which remember we're setting up here. So when we turn, this is also being applied to the class itself. So we just want to untick this option. And what this means now is when we press play, we can click into the viewport and we can now look around our stationary character, and we're only going to move in the direction we're looking, and we're not going to rotate if we're not actually moving. So we will want to set the rotation to be followed as well as we move around. Now again, this is very simple. This is allowed for in the character movement component this time. So you can see the final thing we want to fix is that when we move, even though we're following the direction, the character isn't actually kind of aligning with the direction in which we're moving, which is going to look weird when we add the animations. So what we want to do is go to the character movement component, just type rotation. This one can be a little bit hard to track down. And we want to find the orient rotation to movement. So this is going to basically do what it says. It's going to rotate based on where we're moving. So as that direction is changed, so will the rotation of our character. Now, when we add the animations, this is just going to look as though it's kind of turning to run in the direction in which the character is moving. And again, this just looks much better. So that is all of the basics kind of covered. We've only needed to do several nodes of logic, and we have a pretty flexible kind of movement system going on here. The rotation is being controlled. We have the nice look around panning option, and we're rotating to face the direction in which we're moving. Now that we have our axis mappings added to the project, this is pretty much where we're going to leave these. So in fact, we can create a comment around these, and if we come back and extend them later, we'll know where to look. So after grabbing everything here, we just need to press C. That will give us a comment, and we'll just say that this is the movement logic. You can customize your comments if you wanted to. I tend to just make the boxes darker, the text stands out, and then make the text a little bit bigger so we can see it from a further distance. And a similar thing for the looking logic. With those done, this is nicely housed away at the top of the input graph, so I'll just leave things here. Again, I know that that's pretty much all we're going to need for the movement and the looking. So we can now move on to our action mappings, those binary events looking for either being pressed or released. We'll start with a very simple one, which is going to be jumping, because again, Unreal has an entire system built in for handling jumps. Now we will be doing some of our own custom logic building upon this a little bit later, but I did want to show you one thing to keep in mind is that I'm purposely going through and we'll be adding the very basic implementations, some of which I would class as being perhaps not necessarily the wrong way to do things, but definitely the less flexible. And I wanted to show you the results that we get from taking this approach and then how we fix them. So if you're ever working in your own project, I want you to know not just how to follow these steps, but also to understand what's happening and how you can improve upon some of the features which are lacking. So if we first of all find our jump binding, this is going to be a little bit more difficult. There's a lot of different things called jump. You've got the event on jumped, which is an event which is tracked obviously when someone has jumped. We've got the jump function, which is what we'll be calling later, a check to see if a jump is available, which I'll explain why that exists also later, and a few other things around that. But basically, we're looking for our action mapping or our action event. So that's the thing that we've created in our project settings for the input. And you can see we have a pressed and a released option. From here, what we want to do is call the jump function that I've just mentioned. So again, we'll find jump, and we can see we've got a couple of less options now, and a couple of variables which are popping up as well. So again, these will be relevant in just a moment. But just to begin, if we find the jump function, and we'll call this, that is how you make a character jump in Unreal. Nice and simple. If we come in, press play, then we have a jump function. So there wasn't too much to that, but like I've said, this does come with some restrictions, and we will be making essentially our own version of this a little bit later, but I wanted to get a little bit more in depth to show you just how far you can take this, because this may be perfectly fine for some projects, and also some considerations if you are going to use the built-in jump function, considerations to know about what you'll have to do to make it work properly. Now, the first thing that you do have to do to make this work properly is when you release this, you also want to call the stop jump function. So we're going to call stop jumping, and this just lets the character class know that the requirement for the jump functionality has been released. And the reason for this is if we go on to the player node here and we look for our jump details, we've got a couple of things we can see under the character category. The first one is the maximum jump hold time. Now this relates to something which is often referred to as variable jump heights. You'll see it in games like Mario, where if you tap jump, you go up for just like half a second or something. If you hold jump, then you get a much bigger arc, and it can last almost until you release or until Mario reaches the peak of his jump. Now, the way that this is calculated is that when you press something, this is going to keep running and applying force until something notifies that this should stop. Usually that's going to be that you've reached the peak of your height or that the button has been released. So if we look at this now and try this, it's not going to look any different. We don't have that variable jump height. Even if we hold it or tap it, we haven't told it to have any maximum time that we can hold this. So I'm going to set this to something a little bit extreme. Let's say 3 seconds. This is way higher than you would ever set a variable jump height. But we'll press play. And if I hold this for 3 seconds now, it's almost like I have the power of flight. But if I were to come in and tap this, then we can see that we land almost immediately. Well, not land immediately, but it stops, because that stops calculating as soon as this is called. Now, if we remove this and we press play, this I've now let go, but I'm still flying because it's going to reach that peak because nothing's told it to stop this jumping function. Okay, so this is why it's important. If you're not rolling your own jumping logic, this will be doing things under the hood based on some of the values that we have just here. So we want to account for this. Now, I think I will use this for the variable part of the basic jump. I'm going to set this to something more realistic, like maybe 0.3, 0.5. You can see if we can get some variable jumps going on. So that's a tap, and this is holding it. So that feels okay. It doesn't feel okay because the gravity is disgusting. And this is another problem with the default character class, is when people don't account for that we're using a 1 times gravity force on a mass that may not quite relate. And it makes things feel a little bit floaty. We're in the air for a bit too long. It kind of feels like we're floating or hovering down. So that's something else we're going to improve on the polish pass, but just something to keep in mind. So when I say it feels good, I mean that it feels as though we are getting a variable jump height. I think the gravity still needs to be changed. Now, the other thing about the jump function I wanted to mention is we have this jump count. So as you might expect, if we set this to something like 2 or 3, we can get a double or a triple jump, and you can send this as high as you wanted. Now, this also has some limiting features. The main thing is a brief overview. When we get to adding the wall jumps, because this is all calculated and tracked internally, the maximum jump count doesn't get reset until a function, which is built in. We can find the onLanded function. So until this is called, the jump count that we have here doesn't get reset. And unfortunately, for some reason, we don't have access to override this variable. So we can get to the current jump count and we can change the maximum jump count here, but we cannot set the current jump count. Ideally, what we'd be able to do is set the variable ourselves. But what this means is that if in some games, if you remember, like you can do a jump into a double jump into a wall jump, and then you can keep wall jumping. Or if you've only jumped once, you can do a wall jump, and then you still have your double jump retaining when you leave, so you can get a little bit of distance after that wall jump. Unfortunately, it doesn't work here because it doesn't get reset unless you literally meet the criteria of landing, which is checking a surface in the Z velocity below where you are. And obviously walls generally don't count as landing, which means this won't be called. So this is one of the limiting features of using the jump and the inbuilt double jump system, which is why by the end of this content, we will be rolling our own version. But again, I wanted to make sure that we cover the basic implementation so you can see what you might come up against. So we're going to leave this for now. I would recommend adding in a double or triple jump, and you can try adding in 5 or 6 or however many you want, and you will jump until you reach that cap. For testing, it's going to be easier to test this with a double jump so that we can see exactly when this is called and how this gets reset. Remember, this isn't just about getting to the end of a really polished way of implementing the character. I wanted to show you around how the character movement component and the class itself is working, so you're more familiar with those limitations, how to work around them, and what it provides, because it still provides a lot of really useful functionality. So that's jumping, and we're going to leave that here for now. We will be doing something with this a bit later, so maybe we can keep the on event landed. This won't be doing anything right now, but we will need it in the future. What we're going to move on to is our walking and sprinting. So this is very simple. We've already seen that we have the character movement component tracking the walking speed that we have. All we really want to do is when we either have the walk button or the sprint button pressed, we want to change what our maximum movement speed is. What we'll do first of all is we'll find our walking input binding. So that's our action event. And we will get the character movement component. So like with any other component, we're going to control drag this in. We will set the movement speed, which is our maximum walk speed. And we can actually set these values as well as getting them just here. So we're going to set the max walk speed. This will be problematic. You can probably see that I've missed a step of the logic here. If not, then again, this is why I'm doing it this way first. What we're going to do is we're going to directly multiply this. So we'll multiply this by, let's say, half of the current walk speed. And of course, again, we can do that by pulling from the character movement component. I just press Control W to copy the component. Control W copies and pastes in one go. We're going to get the max walk speed. And we're going to plug this in here. So whatever the maximum walk speed is, we're going to half that, and that will be our new speed when we have the walk button pressed. So if we come in and press play, we won't do anything just yet. Remember, I have this set to control, so I'm going to press control, and you can see we slow down. When I release this, we're not going to go back up because we haven't done that half. But the problem is that if we press control again, we're going to half that again, we're going to half it again, and we're essentially just going to keep halving it until we can barely move. So what we want to do, we don't want to affect this directly. We want to come into the event begin play. In fact, we can cut this. We're not going to plug that in just here. So we'll cut that from here. I'm going to paste this back in, and I'm going to promote this to a variable. I'm going to call this one default walk speed. And we're going to plug this in to the begin play. So now when we start playing, we're going to keep track of what this was set to before we've touched anything, before anything has been overridden or affected. Then on our input graph, we're going to move this a little bit. We're going to need a little bit more space because we're going to set the walk speed to be half of what the default walk speed was. So we know that we have the default walk speed set to 600 because that's what we have here. So on begin play, it's going to grab this value. We're going to set the current walk speed to half of that. And the really important thing, of course, is that when we release the key, we're going to plug this in and we're going to make this return to default walk speed. So nice and simple. Hopefully that makes sense. So again, if we try this one now, we can come in, we can move around as normal, hold control. We can see we slow down a bit, let go, and we go back to our normal speed. A little bit hard to see perhaps, but I think having these pillars here gives us a good kind of reference of how fast we were moving past them. So that is the walking, and you can probably imagine that sprinting is going to be very, very similar. So we'll start by getting our sprint action event, and in fact, I'm just going to copy pretty much all of this and plug this in just over here. What you might want to do is promote this to a variable as well. So we'll promote this down here. And I'll name this one walk speed offset. Just to keep this nice and clear of what's happening, maybe that isn't too easy to read. So we're multiplying our default speed by our walk speed offset. We're essentially halving the default speed. And in a similar way, what we're going to do is I'll promote this to another variable. I'll change it first of all. And just in case you're not aware, when you promote a variable that already had a value plugged in, that will automatically be applied to the variable you've created. So walk speed offset is automatically 0.5. Now I know from testing that I want the sprint speed not to just be double, but I want it to be 2.5 the default walk speed, because this plugs in quite nicely to how I'm going to set up the animations a little bit later. So I'm going to promote this to a variable when it's set to 2.5, and I'm going to call this one sprint speed offset. So the main reason for this is it just avoids us having those what are referred to as magic numbers, just variables that don't really have any context outside of being plugged in. You'd need to double check what it's all doing to get an idea. Whereas this time we know that we're multiplying the default walk speed by the sprint speed offset to get a value return. So it just makes a little bit more sense when reading it back. And it also means we can very easily and quickly change this. So we don't need to jump into the event graph. I can just grab this over here, change this if I wanted to increase it or reduce it. And it's just easier to maintain your code when you turn things into variables when there's that option. So this will work again. We know that's pretty much going to work immediately. So we're going to come in and we can now sprint. So we're getting that 2.5 times speed. We let go. We're going back to normal speed. So sprinting and walking, also very easy to implement. And these pretty much as in-depth as we need to go. So I'm going to create a comment around these, and we'll just call this the movement speed offsets. And in fact, I've just added a kind of post note there saying that this is to do specifically with the sprinting and walking. So again, it's very easy to find where these are in the input graph. Now, something I've mentioned a few times is to do with the speed at which the character's moving. I've really only touched on the movement speed for walking. We also have crouching, which if we were to do a simple test with, let's just hard code in an input here for input key C. So if we type key C, we'll get this, which is a very kind of standard crouch button. And what we can do, again, there is built-in functionality for crouching, so we can just search for crouch. And like with jumping, we want to track this so that when we release the button, we uncrouch. Now, I don't have anything in the project specifically for crouching, but this is the functionality you can make use of. And what I wanted to mention are a few things that this will do. So if we press play and press C and try to do this, we'll see that nothing happens by default. Now, the first thing we want to do is grab our character movement component, look for the crouch category here, and enable this as a movement capability. So we're going to tick the can crouch, come back in, and we'll see there's a pretty horrible snap that we get from crouching. What's happened is if we come in, press the capsule component, and we're going to set this to be visible. So we're going to find the rendering options, untick this from being hidden in game, which basically means we'll see the capsule collider. And what is happening is when we press C, this is being halved. So we've got something called a crouching half height. So if we type crouch again, we can see we have a crouching half height. And this basically means the size in which the capsule is going to be set to whilst crouching. We also have a default speed for crouching, which is half of the walking speed. So two things happen here. The capsule gets shrunk, which is why the camera snaps down, which feels quite horrible. So if you're implementing this in your own game, you're going to want to apply a lerp or something to ease that camera offset. And then you can see the movement speed is slower as well. So crouching is also accounted for. Obviously, the idea of the capsule going down is you can now crawl under different surfaces. But like I said, you do get that kind of uncomfortable snap because it's so quick. Now, one easy way that we can offset this, because we have a spring arm, is we can come in, and in Unreal 5, you get this weird thing where all of the values collapse if you were searching for something. So click off, click back on, and everything's collapsed back down. We want to get the spring arm, and we want to apply a camera lag, and we'll press play. And this is a nice simple way to kind of ease that animation of the camera going down with the capsule half height. And that's just because it's the spring arm's connected based on the height of the capsule. So that's crouching. Like I said, we're not going to fully implement that in the project, but I wanted to at least cover it slightly. So I'm just going to, we generally don't hard code inputs, so I'm going to remove these, but that is how you change the movement speed and things if you wanted to use crouching. Make sure that can crouch is enabled. And then the other thing I wanted to mention is that we've touched on the walking speed quite a lot, but we also have different options that the character can take. So I'd recommend just reading through all of this when you get the chance, looking at the different things which are being accounted for in the movement component. So we've got our walking category, which is what we've been using so far, but you'll see that you also have things for jumping and falling, which is where the default velocity comes in. So we could double this, or roughly double this, and we'll get a double jump height. So we're now controlling how high we jump based on this value here. So we've got loads of things that we can do for jumping. I'm going to set this back down and we'll come back and play around with these again in the polish phase. But it's going to be nice to keep these default to see again why I would think, and I think a lot of people agree with this, why the default character movement that you see with the Manny the mannequin is generally just looks a little bit sloppy. And it really kind of shows that a new person might have come up with that project and left the default settings, not knowing what to change. So we're going to leave this so we can have a nice comparison at the end of the content. But then on top of this, you have other options as well. So you've got the movement type of swimming and the movement type of flying, which is really cool, which means what you can actually do up here is we can change the default land movement from walking to something like flying, which will actually disable gravity. So if we now come over here, it feels very floaty. So I let go and I'm still kind of floating along because the friction's reduced. And you can see there's no gravity. So if I were to put this back to walking, although we haven't seen it before, you would expect the character to fall off the edge like so because gravity is automatically enabled. And another thing to note with gravity as well, which is quite important, is that is enabled on the character movement. So the gravity scale of 1 is what is controlling that. So if we set this to 0, then that will let us kind of float off into the distance as well. Okay. Again, what a lot of people will assume is because the root component is the capsule component, they'll assume that the gravity is enabled here, and it actually isn't. The physics isn't simulated on the capsule. And if we did simulate physics, we then get like a weird battle of movement and nothing happens. You can't move at all because the gravity force is too high on the capsule component. And then what you do get is the chance that this is going to start rolling over. If there are forces applied, then the capsule is going to roll over and be pushed around. So do keep that in mind as well. Untick the simulate physics, go back into the character movement. One other thing that we can look at, the other values. So if we change this to swimming rather than flying, then of course this is going to change the movement speeds that we have. So swimming is like very sticky and has a much slower acceleration and also much harder to turn around in things. And if we wanted to affect that, if we change the movement mode, then of course you need to remember to come down and change the maximum swimming speed and the values assigned to that. And these are also things that we can change at runtime. So what you'd normally do if you were entering some water, you would change the movement mode from the character movement component. So you can set the movement mode to be from one of those enumerators that you want. So when you enter water, you're going to change it to swimming. When you leave, you're going to change it back to walking. If you have a flying option, then you can change it to flying. So again, the character movement component has a lot of different options that you can make use of as long as you know they're there. So that's why I'd recommend just taking a look through. I'm not going to go through all of them. We're making more of a character for platforming, like a third-person character or a 3D platformer. But there are a lot of things that you can do here, so it will be useful to know about them. With the very basics of the character movement implemented, we can move on to improving this somewhat with our animations. So we want to go to the meshes to begin and select one of our skeletal meshes. Right click on this, go to the create option and select the Anim blueprint. This will create a blueprint class specific to animations and it will be based on the skeletal mesh that we choose. Now, because both of the skeletal meshes that we've imported both make use of the same skeleton, this means that we can swap between the meshes and share this one blueprint. For naming conventions, you tend to have ABP for animation blueprint underscore something. So I'll just call this ABP underscore player. With that done, I feel this kind of belongs more in the animations folder. I'm just going to move that over to the other folder. We'll go into the animations folder and we'll open this one. And inside of this, we can see that we get a couple of different tabs open just here. A quick demonstration or example of what our player is going to be doing. And we have the animation graph, which we'll return to a little bit later to fill in the general flow of what should be getting driven into the final animation pose based on what the player is doing. And then the event graph to drive the logic, storing variables, very similar to any other blueprint. So the first thing that we want to do inside of the event graph is to store all of that information. We can see here it gives us a default try get pawn owner, which is going to check against the thing which is controlling this animation, which ideally is going to be the BP underscore player. Now I'm going to move this up a little bit. We have an update animation here, kind of running like an event tick. And we also have an equivalent to the begin play. So I'm going to find that by searching for the event blueprint begin play. This is the animation version. So that we don't need to cast constantly, I'm just going to cast and check if this is our BP underscore player. So we can do a cast to BP underscore player base, and we'll plug this in here. And as you're probably familiar from pretty much any other Unreal Blueprint content, is we're going to promote this to a variable and use this reference to find our information a bit later. And I'll just call this one the player reference. By doing this here, this does make the update a little bit less safe because we may not have this information when we begin the event tick, essentially. So what I'm also going to do is a quick is valid check. So I'm going to control drag in the player ref. We'll do an is valid check from this. And this just means that we can cast once more if we don't already have this. I'm basically going to take this logic, control W and duplicate this down here. So if this isn't valid, we're going to try again and see if we can store this as a new reference. And only if this is valid, then we'll find the information about what our player is doing. A few very standard things we'll need with the player reference. So we'll control W to get another copy of this. The first one is going to be the velocity. So we're going to drive the idle, move, run animations and so on based on how fast we're moving or if we're moving. So if we just type velocity, we can do the get velocity function check. We probably don't need to know all of the directional information, so we can turn this into a float. So we'll do a vector length. If you were doing something a little bit more kind of in depth than we're going to go, where vertical movement might be important versus horizontal movement, then you probably would want to promote this to a vector. But I know for our examples that we're just going to be using a float check here, and then we'll promote this to a variable. I'll just call this one move speed. Again, just moving things into place to keep things manageable. The other thing that we want to know is rather than checking against this information to check the velocity vertically and horizontally and get all of that information, we can make use again of the character class and the variables that it's tracking to check if we're in the air, because we're going to want to swap between falling and idle animations if there isn't any movement going on. So what we're going to do is we'll get the player ref again, and we'll pull from here and we'll check is falling. So we can get the Boolean from the character movement component, which is tracking constantly whether or not we are grounded. And this is kind of checking our vertical speed for us. And again, we'll promote this to a variable and we'll call this one B is in air. So because this is a positive return, this means that if we are falling, then of course we're in the air to be falling. So we'll just shorten that a little bit here. There are probably a couple of things we'll need to come back and add here, but for now that is pretty much everything that we've implemented based on our very simple movement paths. So we'll come back in a little bit later and probably add a couple of more things just here. With these values ready, we can return to our animation graph and start adding in these animations. We can check these values and drive what should be displayed. So we'll go to the anim graph. Basically what we want is a selection of checks to tell us what we will be plugging into the result output pose just here. Now the first thing we need generally is going to be a state machine. We do this by adding a new state machine. We can press F2 to rename this, and I'll just call this one locomotion. So this is our locomotion state machine, and this will basically be a selection of branches and checks to decide which state to enter based on the information that we're tracking. This is going to need to be plugged in here. And again, we're going to need to come back and do something a little bit later. We'll just remember that there's going to be something we need just here. So remember how to get to the anim graph. If we drive the basic movement first of all though, from the entry pin, so as soon as we start playing, regardless of what's already been tracked, the first thing that we're going to want to enter is likely going to be a new state. And that state is going to be our idle or running information. We're going to assume that we start grounded. So I'll name this idle/run, and we can see if we hover over this, this is expecting an output animation to provide. So a really simple implementation of this for something like if we were to just assume that it's always going to be idle, would be coming into here, going to the asset browser, dragging in the idle animation, and simply plugging this in. Now this will actually work straight away, and you can see it's now showing what the idle animation will be doing, and it runs through this whole state for us. So it knows that because the only thing that we can do is come into the entry pin and go straight to idle run, that we're then going to always play this idle animation. So in fact, we can test this as we go along. If we go back to our player blueprint, select the skeletal mesh component, navigate to the right-hand side in the details panel and change the animation mode to the Use Animation Blueprint if you don't already have that selected. You can choose between single animations, so all of the animations we've brought in could be used as well, but we want the blueprint in this case. And we're going to go to the ABP underscore player that we've just created. If we compile that and press play, you'll see that because, again, it's the only animation we have, we now have our idle animation playing in the level, which is pretty cool. What we now want to do is we want to extend this a little bit because, of course, if we were to begin moving around, we're just idling whilst we're running or moving. It seems as though I still have this in the swimming movement mode. So I'm just going to go back to the character movement, change the default land movement in case you left this to the same thing, and turn this back to walking. And then if we press play, we can double check that we are indeed sliding around, but in the idle pose. So we now want that to be updated to either walking, running, or sprinting, depending on the speed at which we're moving. Now we can do this rather than doing a bunch of branch checks or speed checks in our state machine. What we do instead is we can make something called a blend space, which will blend between multiple animations based on a value that we're going to be passing in. We want to create a 1D animation. So one-dimensional, we don't need to worry about different kind of rotations or anything. It's just going to be a flat animation between either 3 or 4 different animations based on one speed. So we do that by going to animations. We're going to create an animation blend space. Now, blend space, the default version, will give you a 2-dimensional blend space, which will be for things like if you wanted to aim sideways and up, then you need to have a blend for the horizontal and vertical offset. We don't have that. We just have the horizontal movement of the speed at which we're moving. So we need a blend space 1D, and we need this to be based on the Devi skeleton. And we can call this one, I'll just call this one blend underscore idle sprint to indicate that we're moving all the way from idle to sprint, which will kind of encapsulate walking and running as well. If you wanted to be very detailed, you could say idle, walk, run, sprint if you wanted, but I think we can kind of shorthand this. So what we have here is our one-dimensional blend. We can begin this by dragging in the idle. So we know that the idle is going to be the very start point. If there is no speed being applied, then we're going to be in the idle state. Next, we're going to want to move to our walking. So if we're going a little bit faster than nothing, then we can shift and left click, and you can see that we're then blending between our idle state and our walking state. So then the next one is we're going to bring in the run. So I'm just left clicking and dragging. And if we left shift and left click, then we can drag this across from walk to run, seeing that we're just swapping from the full walk animation here to the full run animation here. And the final one is sprint. So I'm going to drag sprint right at the end. And if we left shift and left click and drag again, then we can drag this all the way to sprinting. So when we're at maximum speed, we're going to be sprinting. And what we'll be doing is we'll be using this blend space. So in fact, we can go back to the animation blueprint. We can see that we have the new option here, the blend idle sprint. Drag that in here, plug that in here, and we can get rid of the idle. So now this entire pose is going to be controlled based on this one blend space. We can see it's asking for a value. The value is a float. So we're going to use, of course, our movement speed. So the animation to be played is going to be based on the speed at which we're moving if we're grounded. Back in the blend, what we want to do is we have the axis settings here. We can drop this down. I'm going to name this one to move speed just to match the variable that's syncing up with it. You could call this anything. This could be velocity, horizontal movement, whatever you wanted really. But move speed just kind of makes sense to sync this up. Now the values here are a little bit small. 0 is a minimum. Of course, if this is at 0 down here, then we want to be an idle. 100 is a maximum. If you remember how fast the player can move, the maximum speed at the moment is on the character movement, which is 600. And that will be then multiplied by 2.5, which is the sprint offset. So what we actually want is the maximum axis on our blend space to account for sprinting as well as generally walking and standing still. So 600 times by 2.5 is 1500. So the maximum axis value is going to be 1500. So if we are moving and you're sprinting, then that should be the only time we should be able to enter in this value just here, which you can see has now been updated to a higher value in that small tab that kind of hovers when we're using this. So the next thing is making sure that we have these set up as we want them as well. So I think we should probably enter walking a little bit faster. Otherwise, that looks a little bit slow, and I think we're going to reach this kind of speed quite soon. So we want to move this node down a little bit. So the way that we can do this, I'm going to hold left shift, click the drop down here for blend samples, and then click it again to drop everything down in one go. And what we want to do is we want to untick the snap to grid. Snap to grid basically means that when we drag this, we can only be on these grid lines, which are not too flexible. So for walking, I'm going to untick this, put this to a custom value of, let's say 150. That's going to feel, I think, a little bit more correct. So we reach the full walking animation at a speed of 150. And then I'd say the full running animation, it may be 600. So again, we'll need to unsnap the grid option there. So we can move this somewhere in between. And then 1500 will be our sprinting speed. So now that sets up our complete blend space to account for all of the different movements that we've plugged in. And if we save this, because we have that movement set up already, we're already tracking this movement speed. We're going to plug in this blend space, and then this is all going to be driven based on the velocity. And this is basically, as we're using our walk speed, the velocity is trying to reach this maximum walk speed that we're playing with. So if we press play, if I don't press any buttons, we can see that we go into pretty much a run animation straight away. If I hold control, then that's slowing us down and we do our walk animation. And if I hold shift, then we accelerate up to the sprinting animation. And again, that all kind of blends between them quite nicely. So the idea is that the system is trying to find a kind of midpoint between where the limbs are in the full idle and the full walk, or between the full walk and the full run. It's kind of making a somewhat procedural animation based on where the limbs are in the full versions and offsetting those midway between. And that makes everything look very smooth when we're going between different movement speeds in game. So I think that looks pretty cool. And we now have the basic movement in for the ground at least. Now this isn't accounting at the moment for jumping. So that does mean that we're just jumping off into space. And because there is some movement happening, we're playing the walking animation and of course floating off indefinitely. So I've probably turned off the gravity scale. So I'm going to turn this back to 1 as well, just resetting things from the previous topic. So now we can jump, we'll fall back down, but we will play the walking animation, which is fine. That is the next thing we'll be fixing. So we now, inside of our locomotion, we have the basic state to check for, which is whether in idle or some type of grounded movement. What we then want to do is check whether we're just entering or exiting a jump, and then we're going to disable this from happening if we're in the air. So that's going to account for our vertical movement. The way we do this is we can drag from here and we'll place a new node. We want a new state, which is going to be, first of all, our start jumping state. You can see this one, because it's conditional, unlike the entry, where this is just going to enter this regardless. We now have this conditional thing. So if we double click into this, we can see that whether or not we can enter the start jumping. The entry for this is going to be very, very simple. We're going to control drag in the is in air boolean and plug this in. If we're in the air, then we're just going to assume for now that we're going to start jumping. So what we can do is we can come in here and we can provide the jump start animation. Now the reason this has been split out is just to make the jump look a little bit more polished, rather than, again, kind of like with the mannequin, what we want to avoid is that messy looking jump where it kind of loops, where regardless of how long you're in the air, it just loops as though it looks like it kind of kicks out and then reloops the falling kicking animation. It just looks a little bit janky. So what we have instead is very simple, but we have a jumping up animation, which is the arms going up to imply that force. We have a air falling animation, which is a little bit more subtle than the mannequin. So we can loop this and it's not going to look quite as uncomfortable if you're in the air for a little bit longer. And then we have a jumping land as well for when we hit the floor. So we've got that whole cycle to account for the different states at which you might be in the air. So this is going to be one of those improvements we'll be making on top of the default character that you're provided with. Back in the locomotion again, we can now go from start jumping. So if we are in the air, we now want to check perhaps maybe how long we've been in there and then do our next thing. So we'll add another state from start jumping, and this will be our jump loop that we've just seen. So assuming that we're staying in the air for a little while, we're going to come straight into this and we will drag in the jump loop, or the air fall, we've called this one. So this is the one which is going to loop for as long as we are still in the air. And the way that we can drive this one, if we go back into the locomotion, again, that conditional check, what we can do is we can find out the remaining time that we have for our jump start. So if we type in jump start, we'll get a few different options here, and we can see we've got some information about how long that animation has left to play out. If the time remaining is less than a certain value, and we can come back and tweak this a little bit, but I found that something less than about 0.3 of a second left on the jump start animation is a good time to start playing this looping animation. Then we're going to merge into this one. We'll play this, and before it completely finishes playing out, we'll start considering playing into our jump loop. And then this, because we've got past the in-air check, for as long as we're in the air, this is going to kind of stay here. So one thing we do want to do is make sure that when we're inside of the jump loop, we're going to select this animation and double check that this is looping. And what we want to make sure it isn't looping is the start jump animation. So we're going to come in and we'll untick the looping. We don't want this to get stuck in this animation looping the start jump. We want this to play once, which is that initial launch, and then we'll let the state machine handle the rest. So these are very simple things to forget, so I just wanted to make a point of just considering whether you think you want an animation to loop or not. We've now accounted for jumping in the air or starting a jump, being in the air for a while. We now want to exit our jump. So we're going to pull from here, we'll add another state, we'll call this one end jump. And we can plug this straight into our idle run as well. We're going to need to account for both of these conditionals, and we'll also need to give this an animation. So when are we going to end jump? We're basically going to leave this state and enter this state when we're no longer in the air. So very similar to how we start jumping, it's just going to be the reverse. So if B is in air is not true, so not Boolean, plugged in here. So if we're no longer in the air, which means we've probably just hit the ground, then we want to enter this animation. This animation is going to be our jump land. And again, we only want this to play once. This isn't something which is going to keep looping. If you think of what the jump land looks like, just have a quick look over here. Obviously, we're not going to want that to keep happening for that one time that we hit the floor. So we're going to come in and we'll untick the loop animation. And in fact, looking at this, I think we probably want to account for this, or to have this account for the movement speed at which we're going. So we might want to make another blend space of this, but we'll see how it looks. And that might be one of the polish and improvement passes that we make. And then the final thing is we want to see if and when we're going to go back to the idle run. And just from testing, something that I find works quite well, very similar to what we've done previously. This time we're going to want to get the time remaining for the landed, or the jump land animation. So we'll search jump land, we'll get time remaining. And this one is actually going to be quite lenient. We want this one to be quite a high check of 0.9. We'll plug this in and we will see how this looks. Now again, there are going to be a couple of things we want to come back and do. I think we probably will want this to be a blend space. We'll also want to account for wall sliding, but we haven't got to that part of the movement yet. We just want to make sure that we can get this core loop working. So if we press play, we can see how this looks. So we're still in the idle walk run animation. That looked okay. I mean, we're getting the launch animation. I think the falling looks pretty good again. Because it's more subtle, we can play that and loop that a few times and it doesn't look too bad. The falling animation, we're not getting the landing play at all. So maybe this is too lenient. Maybe my testing worked out in a slightly different way and we're going back into idle too soon. There we go. So now we're getting that landing animation. But this is what makes me think that we're going to want to add a blend space here. Because if we're moving, we kind of slide across and play the landing animation, which is what I thought was going to happen. So maybe something like the other value, maybe 0.3 here would be better. But I think we will want that blend space to maybe blend from the landing animation to like a slow walk or something. So rather than leaving that for a polish pass, because that does look a little bit rough. And we know that looks rough right now. So back in the animation folder, what I'm going to do, I've just been thinking about the way that this might work. And rather than just accounting for just hitting the floor, so that landing animation and a slow walking animation, I think we might be able to pick up enough speed that we could potentially be between running and sprinting. So what we can do is we can just copy, duplicate, so Control W to duplicate the idle sprint. We'll call this one blend underscore, we'll say full land to walking. So some of these names can become a little bit nonsensical, but I think when you're inside, it's all going to make sense. Now this will be a little bit different. So we're going to want to untick. We can use most of this, which is why I think we can just copy this. We still want this to be driven from the move speed. We want to unsnap the idle. In fact, we can remove the idle. Yeah, if we remove the idle altogether, this would be the only thing which is different. And we can replace this with the jump land. So now we'll go from jump land to a slow walk. And you can see it's kind of offsetting the arms for us. So we're getting a nice kind of swing going into the walking animation, but still accounting for the landing animation. So it looks like we've hit the floor. And we can do that from all of these in all the way up to sprinting. So we'll at least pass through this. This might be better as a 2D blend space, but I think that's going a little bit in depth for something you might only see for like a split part of a second. I think all of the speeds, they can remain pretty much the same. Keeping that from idle to jump land, I think will look pretty good. It's definitely going to look better than kind of sliding along the floor. So what we can do is we can go back into the locomotion, back into end jump, and when I replace this with our full land walking, I poured the wrong one in. So we're going to get the full land walking, pour this in. And again, this is going to be based purely on the movement speed. So we can control drag this in, plug this into the move speed, and this will only happen when we're out of the air anyway. So when a grounded check has been made, and this is going to kind of merge back into the idle run. So it just means that we'll get hopefully a little bit of that animation going from the landing. Now I think maybe that was why I want this to be higher if we're counting for blending. Okay, so we're not resetting something here. I think the problem we have is that we're stuck here because we want to, again, make sure we don't loop this. So this is why it's important not to forget to unloop something. So we want to make sure that that comes out of that state and the value is being tracked. And we have some more bugs here to fix. That's fine. These are good sometimes to see these in production bugs, so we can kind of debug through and see what's happening. So one useful thing to know is if we play from here, what we can do is we can see that this is going to show us what's happening as I play. So as I start jumping, I can actually see that I'm pressing jump and it's not getting up here. So we can find out why. We can go into the event graph and see what's happening over here. So I'll press play again. And we can see that as we begin, want to make sure that we're possessing the right thing. So this is the one that we spawned in, not one of the characters I had manually placed. So we are getting the correct values, which means we can now check in the locomotion. So I'm pressing running, I've jumped, it is going in, we're hitting that, and you can see that we're staying in the end jump. So this is where the problem is. And let's just take a look of why we might be staying in the end jump. So we're hitting the correct isn't air check that is being reset. I think the problem might actually be if we go back into this check here, what we were doing is we were checking for an animation which is no longer being used. So we're checking to see when this ends. So we now want to make sure that we're checking for the full land walking. So we want the time remaining for the full land walking, and we'll plug this in. I think that might have been a really simple bug causing what looked like a serious issue. And there we go. So we're getting all of the states moved back around as we want them to be. I've jumped off the edge. And that is pretty much the basic movement setup done. So like I said, you might want to come back in and tweak around and play around with this value to get those different movements. Just bring this back in. But we now have the basics of our animation blueprint ready to go. So what we can do is we can then start coming back in and adding our more complex versions of the movement system. Because if you think about it, this is pretty much what a default template comes with, just a simple jump, some landing, and we've even got sprint and walking, which is slightly above what's provided by default. We can now come in and look at adding the more complex things like wall jumping, fixing our double jump system. So at the moment, we don't have the double jump animation playing, so that will be something that we could potentially do next. We can still double jump, but of course, there's nothing kind of indicating that we're still in the air. And the final thing is, just in case you forgot how to do this, we're still showing the capsule. I'm going to come into the capsule component. We'll go down to the rendering tab, and we'll make sure that we tick this to be hidden in game again. And we're pretty much in a playable state now. But that's looking pretty good for a first pass. For the double jump, we're going to want to head back on over to the player base class if you're not already there. We will need to change and track a few more details rather than just whether or not we are jumping or have stopped jumping. So you can see this kind of works because all of this is being tracked anyway. but we need to know a little bit more information. We need to know exactly what to do when this button is pressed, rather than just letting the system do the jumping logic. So the very first thing is we can just unhook the jump for now, and we'll call this a little bit later. The first thing we want to do is a branch check, and this will be based on the return value of those values being tracked. So remember, we've got the max jump count and also the current jump count. So the first thing we want to do is check whether or not the current jump count or jump count current is less than jump count max. Okay, so this tells us that we do have jumps remaining. We also have a can jump check here as well. So we could return this function, but this gives us specific information based on the count number of the jumps that we have available. Now this could be that we have 0 jumps, so this might mean we haven't jumped yet, or we might still have 2 or 3 remaining based on what we've set the max to be, which means we need another branch check here, just to keep this nice and easy to read. Separate this into separate branch checks. So if we are less than the maximum, which means we can still jump, and the next thing we want to check is whether or not we are falling. So remember that character movement check we've used already. So if we look for is falling, we can get the character movement is falling function return, which is just a Boolean on whether or not we are in the air. And what we now know is that we have jumps remaining, and whether or not we are doing this from the floor or the air. If we're falling, that means we're doing a double jump or a triple jump. Or if we're not falling, that means we're on the floor, which means we're doing just a normal jump. So what we could do is we could say that if we're on the floor, we want to do our normal jump. And if we're not, we're going to want to do the jump again. So at the moment, pretty much the same, but we will again be changing this for a more customized approach a little bit later. But in between this, we want to do something else. We now want to do something which is called playing an animation montage. So if we drag from here and search for montage, we can see we have the play animation montage, which is based on the character, and we haven't created this yet, but this will be our double jump montage that we want to play. So what we want to do is we're going to go back into our animation folder. We want to find the not jump in air, we want the double jump. So we have our double jump animation, which is essentially like another forceful flap, which makes it look as though we're getting that velocity from our body's movement. And what we want to do with this one is we're going to right click, and rather than creating a blend space or something, we're going to turn this into an animation montage. So we'll call this one montage underscore double jump. I like to put it at the beginning rather than the end. And you can see that I've named all of my animations Anim. So what we have is if we made a bunch of these, we'd have all of the basic animations next to each other, all of the blends next to each other, and all of the montages again next to each other. Now what we can do is just double click into this, and we can see it's very, very similar to what we've had already. We do have control over the blend in and blend out spaces. These are things you might want to increase or decrease if it isn't playing the animation as you expect. But besides that, we can leave everything at default as it is for now. And I think for this one, this will probably work as it is. So we want to come back into the player. We can see we can now plug in our montage double jump. And what this means is that we're now going to check. And when we start jumping, depending on how many jumps we have left, depending on whether or not we are currently on the floor, not only are we going to play this jump animation or play this jump function call, we're also going to play this jump animation. Now this won't do anything at the moment. So if we press play and we come in, we can see that we're still just kind of floating up. The reason being is we want to come back into the ABP underscore player. And remember that previously I said in the animation graph, there's something that we want to do in between here. Quite simply, we're going to pull off of here and we're going to create something called a default slot. So we're going to add a slot default. The source is going to again be based on the locomotion, plugging into the outpose. We want to make sure that we keep the slot name as default. And this just lines up with the montage going into a default animation montage slot. And basically what this is doing, for a brief summary, is whilst the locomotion is playing, if a montage is played at the same time through something like the animation blueprint here, which is linked up to the mesh, and this class passes on information that the montage is about to be played to this character mesh that we have here, then for the duration of that montage, this default slot will take priority, and that will be the output pose. So what we should see now is if we do a jump and then a double jump, we get that just the initial kind of double jump animation playing. And that's only going to happen once because we've got those checks in to make sure that even if the button is pressed, as long as these values are being tracked, which they are by the system, until we land and that is reset, we're not able to enter into any more jumping states. So that's really as difficult as it needs to be to use an animation montage. We create the montage from our base animation, make sure that we have a default slot hooked up between our locomotion or your state machines and in between the output pose and that state machine. So nice and simple. We now have something again, it's all coming together now so we can jump around. It's very clear that we're double jumping rather than just doing additional kind of meaningless jumps or force coming from nowhere. It's always important in games to try and visually represent to the player what's happening, even if it doesn't make sense. Obviously, when I say this means something, obviously it doesn't mean that we're applying force from just flapping our hand lightly down, but it looks as though to the player that it's very clear that they've pressed a button and it's doing something new. So this is the basic implementation you'll see of double jumping. This is using purely the information from the character movement component and the values which it is already tracking. Now, like I've mentioned, you may have already started seeing where this is going to fail because this isn't reset until we've landed. So what we're about to do is look at the wall sliding in the next topic. And obviously nothing's there at the moment, but what you might want are essentially, you'll see games tracking wall slide jumps as just standard jumps. And what this would do is this would cap us to the point where we cannot do any further wall jumps if this has been tallied up and is currently more or equal to the current maximum jump count. So that makes it a little bit unflexible, or it means that you have to roll a completely custom wall slide or wall jump functionality, at which point if you need to do that, it's probably best to do what we'll be doing, which is just rolling a completely custom jumping functionality, including wall jumps. So that will all again make a little bit more sense when we start looking at the wall jump functionality. Moving on to wall sliding then, as that will be the final kind of movement that we really need to get in. We're going to have all of our jumping, all of our kind of vertical and horizontal movement implemented at that stage. And we can finish off the animation a little bit later when we're tracking whether or not we are attached to a wall. So we can close this for now. The same for the montage, we won't need that any longer. What we can do is this will be back in the default event graph, and this will be run from the event tick. We basically want to do a couple of checks. The first one is going to be finding out if we are currently falling, so we can do that straight away. And we only really want to be checking for walls if we're not on the ground. So we can just add in the is falling. We'll make this a positive check. So if we are currently falling, then we want to potentially wall slide. To do this, we need to know some information about the environment around us. Specifically, is there a wall? So we're going to do a capsule trace, and we'll do this by channel. The capsule trace is basically going to just be a capsule around our character, and we can use this with the out hit information to get some details about the way that the wall is facing, which way we should be facing, and things like that. First of all, we need to create our capsule. So this is going to be the start and end location is basically just going to be our location. So wherever we are, we want to trace around ourselves. Then the radius and the half height will be essentially our own capsule radius and half height. And I think now would be a good time to just double check that this is fitting correctly. And again, I apologize for the glare here. Do not get a 2080. The cards are a mess. So what we want to do is double check that this is fitting around the character correctly. I think we might ignore a little bit of the head. I'm going to see if closing this and opening it will kind of correct this. This happens in games, it's not just Unreal Engine 5. My system is a complete mess. What we want to do is we're going to get the capsule radius. I think we can turn this down to 26-ish or 25. Turn this down to 25 because we want this to be just around the player's body. We can ignore the head. I'm going to allow for this to go through the wall. And the half height is a little bit too big. We don't need all of that extra above the head. So we'll turn this down to 70. And it's hard to see, but I think he's now just above or just below the capsule's bottom. So that's more fitting. Now we need that to be correct because the next step is we want the radius to be the radius we've just set +1. We just want this to be slightly bigger than our own capsule. And the half height can be the same. So we'll trace to the same height as the capsule of our character. We can see what this looks like by turning on the draw debug type for one frame. So because we're doing this on the event tick, that will only exist for one frame, but it's going to look pretty much persistent for as long as we're in the air. So we can see what we want to do is when we run into these walls, we want this to be green, which means that would have found a successful wall trace. And when it's red, that means we're in the air and we're not finding anything to trace against. So we can see the start of this is indeed working. Two things we want to do. We're going to split the structure pin just here. So we'll split this and we'll use this information a little bit later. The very first and basic thing we want is from the hit blocking. We're going to do a branch check from here. And what we want to find out is whether or not we're currently blocking something whilst we're in the air. If we are, we're going to simply class this as a wall hit. So we'll promote a Boolean or create a Boolean here. Call this one be in wall slide. This is going to be important for our animations. We'll need to track this a little bit later. And we're just going to set this. In fact, what we could do is we can set this just here. So based on this value being returned, rather than doing a branch and setting it twice, we can just set it once here. And that will work perfectly. We still need this information though, because for as long as we are in the wall slide, we still want this branch. As what we want to do is we're going to, the way this is usually done at least, is we're going to manipulate temporarily the gravity of the character movement. So we'll get this and we will set the gravity value. So set the gravity scale. And if this is true, so if we are wall sliding, then we can make this something like half of what it is, which is 0.5. I think it defaults to 1. And then if this isn't true, we're going to set this back to 1, so the gravity returns to normal. So this will at least look a little bit different. And you can see that feels a little bit more floaty for as long as we're on the wall. And then when we leave, we get that normal full speed. Now it's not very obvious because we haven't done the movement improvement pass, and the gravity is still, to be fair, a little bit too low anyway. So to get any real kind of feeling of difference here, we might want to put this down to something really low, like 0.1. And then you can see this is definitely lowered the gravity. So the idea would be that whilst you're still attached, that would keep you going down the wall much, much more slowly. Now the problem is that there's no accounting for the vertical velocity, which means we can float up. So we want to cap that too. But we also want to do a few other things. So one of the first things we can do now that we have this value being tracked, again, very simple implementation. We will be coming back and fixing this, but we want to visually represent this with another animation state. So if we go back into the animation blueprint, we'll go back into our locomotion, and from the jumping loop, as we're probably only going to enter this from jumping. In fact, we might enter it immediately if we jump straight onto wall. So we'll do this from both of these. So we'll pull a wire from here. We'll add a new state called wall slide. And we'll plug this in. We can just plug another one straight into that state. And we're also going to want to allow this, whilst we're in a wall slide, we might detach ourselves. So we might go back in to a jumping state. That means we're going to need to account for these three. So the simple thing is, the thing that we're going to play is quite simply the wall slide. Now what we want to do, it will say here that these three states haven't been accounted for. We don't have the value tracked at the moment, so we can Control W, our player reference again, and we can now get and promote that new variable that we've made, which is wall slide. So the Boolean we are now kind of tracking on the event tick. We'll promote this to a variable, call it be in wall slide, and this is what we'll use in just a moment. So in the locomotion again, back in here, we're going to go into our locomotion graph. This and this will be the same. It should be quite obvious what these will be. So the condition is quite simply whether or not we're now tracking if we are in a wall slide. If we are, then we want to play that animation. So we're just control dragging these in. And in a similar way, quite obvious again, but this is going to be if we're not in a wall slide, then we're going to return to jumping. We might find after some playtesting, we might find we also want to do a check to maybe idle run. We might end that on the floor, but because this goes back into end jump, that should account for it anyway. So I think this will be fine. And we also want to make sure that this animation is looping because we might want this to loop for as long as we stay attached to a wall. So we now should have some visuals happening. Again, this is probably not going to play the right way. Oh, it does. Okay. So we can now at least see when we're in a wall slide. So this, again, visually makes more sense. The wall slide implementation isn't finished. We definitely don't want it to slide up the wall forever. But the basic kind of loop of checking for that and then representing that back out to the player is at least very, very simple to get across in this base logic. To begin improving our wall slide, we first want to account for the vertical kind of floatiness that we get when we lower the gravity scale here whilst going up a wall. This can be done very simply with some branch check just ahead of our gravity scale being set. So when we're going up a wall or when we are entering the wall slide as we have here from our true state, we first want to include a new branch check, which will allow us to see or check on the velocity that the player is currently moving. With our velocity value, we can then split the structure pin, and then from the branch, we can pull from here. We'll do a less than or equal check, and we want to check that our Z velocity is less than or equal to 0, meaning that we've reached that jumping peak. So we now have no upward vertical movement remaining, and just this one change will immediately make this feel much better. So we can see here that as soon as I press jump, as soon as we hit the wall, there's no change in gravity until we start going down, and then it slows us down. It kind of gives us that feeling of having the friction taking place and slowing our descent against the wall. There are a couple of other things now introduced. The problems with this system are becoming apparent, so we're going to go through and fix these as well. Now, the first thing I like to do is also clamp the horizontal movement. So we're going to also reduce, because at the moment you can slide around on the wall quite a lot sideways. We'll reduce this by directly setting the velocity under these certain circumstances. To keep things a little bit tidier, I'll do this from a sequence node, because what I want to do here a little bit later is we're going to immediately cut the upwards velocity when we hit the wall as well, because I think generally that's going to feel a little bit more sticky, and it's just an approach that I like to take. So we'll come back to the then pin 0 a little bit later. What we'll do to begin is from the second pin, this is just where we'll be controlling our velocity. To do this, we'll need our character movement, so we can grab this one here, and we'll set the velocity through this. As this is a vector, we'll want to do this through a vinterp, and we'll use a vinterp2. So this will just give us a nice kind of transition from our current velocity to our final resting velocity that we want to set this to. Vinterp works that it can take a dynamic input, so something which is changing. So we'll get our current velocity and plug that in. And then the target, we can split this one down. And what we want to do is we'll get, rather than splitting this, we'll just duplicate our get velocity pin. We can then split the structure pin here. And our end goal is we want these to be 0, but we want to maintain the Z velocity. So we'll plug that in here, which means we're going to interpolate from our current velocity on all of the axes, keeping the Z axis as it is, and then interpolating down to a 0 speed on the horizontal movement. This takes in a delta time, so we can get our get world delta seconds, and then this will take an interpolation speed. So we can try a value, let's start with something quite low. So I'll set this to 4. We can find a value that feels pretty good, and then we'll probably want to promote this to a variable, as we've done in the past, for easily being able to update this. So 4 kind of feels okay here. If we double this, then we'll get a good idea of what this value is doing now. So we can see that one doesn't slow us down quite as quickly. So I think maybe somewhere in between that is going to feel quite good. And we can, as I've said, promote this to a variable. We'll call this one wall slide deceleration. And just to note that the way that this works, so the interp speed, we can see that if this is set to 0, then it just jumps to that end goal, which gives us the information that we need, that the lower the value is, the quicker this interpolation will happen. The higher the value, obviously this is going to take longer to ease into that final resting state. The next thing, which is now more evident when we're trying to do this moving across the wall, is that as we're moving side to side and we're adding rotation, we can see that this is being overridden, and we can kind of rotate away from the wall, even though we're still sliding on it. What we'll do to fix this is we're going to come after this pin, and we will just directly set the rotation whilst we're connected to a wall. Using the set act rotation node, I'll split this because, again, we only want to affect the Z axis or the yaw of our rotation. And what we want this to be is some information that we can get from our hit output information. Specifically, we want this hit normal, which is the direction or the normal in which we're facing from the wall. We're going to make a rotator from the X vector. Again, we're only interested in that one Z-axis, so we can split the structure pin. By default, this is going to give us the exact direction the wall is facing. So if we do a quick test here, if we just plug this in first of all and do a quick test, then this will make us rotate the same way that the wall is facing once it gets to that stage. So we can see we don't want that to happen. What we want to do instead, knowing that information, we can add a float value here. We're going to add 180 being the degree offset that we want to apply, and we'll plug this value into the rotation. I'll just add a reroute node here to keep this a little bit tidier. There's not a whole lot we can do to keep the blueprints that tidy in this case, apart from promoting this to a variable, which we might come back and do later. And you can now see that that is rotating the correct way when we hit a wall, and even when we're adding the horizontal offset. I think just to keep things a little bit easier to read, I'm going to move this straight back, and we'll do our gravity offset here. We're only going to want to do that after this second pin has taken effect, as we go through and add the next part of logic. So what I want to do up here is I'm going to run this off of a do once, because we only want to pause our velocity vertically for that kind of sticky feeling as soon as we hit the wall once, and we'll reset this a little bit later. So we'll get a do once pin. We're going to get or set the character movement velocity again. Again, we'll split the structure pin as we'll only need some of the information here. And we're going to set this. So we have a split velocity. We're going to need this again. So I'll just duplicate this above. And what we're going to do, kind of the reverse of this interpolation. This time we want to keep that initial velocity as we hit the wall on the X and the Y. This time we're just going to directly set the Z velocity. So this is going to give us that immediate stop of going up, which means this will be hit much sooner, which means some of the rotation issues that you just saw as well whilst playing should also be fixed. Now before going back in, I'm just going to make a third wall and make this one a little bit longer for testing the horizontal movement. That was getting a little bit difficult. And there you go, you can see that feels immediately much better just with that kind of initial stop being applied. Now we do want this to be reset. At the moment we can only do this once, the very first time we hit a wall. So what I'll do is I'll move this across a little bit. We're going to create a new custom event, which can be called here, just to cut down on the wires going absolutely everywhere in this event graph. I'll name this one wall slide velocity reset. We'll plug this into the reset execution pin. And basically what we're tracking down here, when we leave the wall, so whenever this has been detected that we have detached from a wall, we want this to be called again. So as we can see there, that now means that it's not just going to be that first time that we hit a wall that this will happen. Every time that we detach and jump back onto a wall, we're still getting that initial velocity being set to 0. And then we're doing our lerping or interpolation to the value that we want a little bit later. After watching that a few times, I think maybe a slightly higher speed, I think 8 did feel about right here. I'm going to set that back up to 8. And one other thing has just caught my eye as I was going through the code here, and that is that we're setting these to hard values for the gravity, and in fact just this one. So similar to the problem that we faced with the movement speed a little bit earlier, if we set this, which we will be doing a bit later, the gravity value to anything other than 1, then we're going to be setting this back to an incorrect value. We can get the gravity scale and just promote this to another variable. We'll name this one default gravity and we'll hook this up. The only change we'll need to make is we'll come back down here, we'll control drag in the default gravity and plug that into the reset value that we have here. So now whenever we change this, when we come back to improve our character movement, we'll have not just the gravity set back to 1, we'll have that set back to our default gravity, which will be tracked as soon as we begin play. Now another thing, you could set this to be a more dynamic variable. I think 0.1 from trials that I've done in the past will work just in general. That's roughly what kind of feels good when you're on the wall, as having that kind of extra friction. You could make this half of whatever the gravity is set to, or a tenth of it, or whatever you wanted. But I think generally 0.1, a hard value here, because it's not necessarily related to the overall gravity in the world. This is just kind of faking friction. We can set that to a kind of magic number here. And that's pretty much it. So if we play this quickly, we can see that there's still one thing which is kind of sticking out to me, which is if we are already on the wall and we jump again. So this is actually two different problems. The first thing is we can only get that one additional jump. And the second problem within that is because we're not applying any forward force, any forward velocity away from the wall, we are still technically wall sliding, which means we have set the gravity to 0.1 and we're getting a very slow movement back up the wall again. It looks as though we're floating back up, which is a problem we've mostly solved, but we still have this issue here. Now, there are a couple of different ways that we could approach fixing this. We could keep this check in mind. If we jump again, we could reset the gravity or something, or stop certain velocities if we're still being tracked as being connected to the wall when the jump button is pressed. But we're going to do a complete overhaul of the jump functionality anyway to make these improvements. One, to stop this kind of floating movement. And also, like I've mentioned, we're kind of capped at how many times we can jump, even in wall jumping scenarios, because of using the default double jump implementation. I think with regards to the actual wall slide setup, this is very good. This is going to be feeling pretty good to interact with. And we would be fixing a problem which is going to be solved in a different way when we get into the next topic, which is improving our jump setup anyway. To start making these improvements to our jumping system, the first thing we'll need to do is head back on over to our input graph. We will need to take some of this code and pretty much repurpose a little bit of what we already have. So the one thing we're always going to need to do is track when we release the jump button with stop jumping for as long as we continue to use our default jump functionality. I think for the most part, we probably will still be using this, but I will be rolling a kind of custom jumping implementation as well. And I think we can keep both of these branch checks. We'll need these, and we could just either unhook or delete these for now. I'm going to delete things just so that we have a nice kind of clean slate to go from. So hopefully this will make things less confusing as we go through. One of the things which is really causing us an issue is the fact that we're not able to reset our jump current count. So the first thing is that we're going to completely remove this. We will keep our jump max count. This can still be used. So we can still base what we're tracking on the player, the character class details from the jump max count. So we can keep this as a double jump, but we're going to pull from here and we'll promote this to a variable. I'll just name this one jump count. So it's a little bit different so that we know it's our own. And this is what we'll now be using to track our number of jumps that have been made against the maximum jumps that we're allowed. Because this was never being changed, it never needed to be reset. We don't need to update this dynamically. We're fine to carry on using the default character version, and that should make things a little bit less confusing. We'll then want to do exactly the same thing as we were previously. We want to check whether or not we're falling, and we'll do different logic based on this. So we're first going to check that we can jump. Nothing's really changed there, just the way that we're checking that. We then want to check whether we're doing a ground jump or an aerial jump. Pretty much exactly as we were doing before. We can approach the ground movement first of all. This will be the easiest. So if we do have some jumps available and we're not falling, which means we are grounded, then we're just going to do our standard jump. So like I said, we're going to be calling some of the functions we already had, but hopefully just re-implementing it kind of reinforces what we're doing. So if we're on the ground, we're going to make use of the standard jump function, which is why we're keeping this over here. I had a feeling that we'd be using this again. One thing we do want to do now is this will, as you've seen before, this will update the internal jump count current, as it's called, in the character class, but that's no good to us. So what we want to do is we're going to control drag in the jump count value, and we'll use an increment operator here. So this will just add one to the current jump count, and this is going to be how we start tracking our own values, and we'll be using this, as we've seen just here, a little bit later on in some of the other functionality. So now there's an extra step we need to take. We actually need another branch. So we'll do another branch check here. And this one is going to be based on whether or not we are wall sliding. So I'll drag in the in-wall slide. And we're now going to need to account for another couple of different types of jumps that we can do. So these are quite simply whether we're doing a double jump from the air, or an additional air jump, we should call that, or whether we're doing a jump from the wall, so a wall jump. The simple version here that we'll do first is going to be our air jump. And what we want to do is play that animation that we had before. So play Anim Montage. And we're going to fill that with the double jump animation. Nothing else needs to change here, but there will be two ways that we can approach this. So the first way is going to be reusing our jump function. And this would work perfectly fine. Of course, we need to make sure that we also, again, always track our own custom jump count now. If we just do a quick play, we'll see that this looks pretty much exactly like what we had previously, just with an additional check. Okay, so really nothing much changed there. One thing you will notice is that you no longer have it resetting. So once you've jumped twice, we don't have that being reset at all. Simply because we don't have that being tracked, we need to do that on the onLanded function. And we could probably do that now just because this will help us when testing. So all we want to do is whenever we land, we want to make sure that we reset our jump count. So another quick test, and we can see that we can jump twice, hit the floor, and then we can jump twice again. So nothing really looking very different here. And that's the first thing, is I kind of want this to have some variation. So I wanted to kind of show that we're using a different kind of jump if we are in the air. And the way that we can do that is by using another built-in function, which is the launch character. Now the launch character just is another function on the character class. It takes in a velocity, and we get the option to override the X and Z velocity of our character, which I will tick to true for these. And what this allows us to do is we can change the value that we'll be placing in here. So what we want to account for at the moment is we're going to get the current velocity. We want to add a vector to this to apply the final offset of the character launch. Now what I'm going to do is split the structure pin here again. We only actually want to affect one thing. So we're getting the entire velocity, which means we'll be accounting for the X and the Y movement. But we only want to override or update the Z velocities, so adding velocity upwards. So we're not going to add anything to the other axes, but I will be adding a value of, let's say, I think we're currently using a value of 420 for the Z velocity. We'll change that a bit later. So let's plug in 600 for the air jump, so it feels a little bit different to the standard ground jump. We'll plug this in here and replace that with the increment pin as well, and we can test this. It's going to feel, again, pretty much the same. But we now have a little bit of extra flexibility with how we use this. We're not tied into using the jump function to automatically tally the current jump count that was previously being tracked. Again, we can change this out now for anything because we're doing this check ourselves, which means we can get a little bit of flexibility here. And generally, you'll find that the air jump is either weaker or more powerful than the ground jump. And if we were doing that with the default jump functionality, we would have had to have come in, checked whether we're doing a ground or an air jump, grabbed the character movement component, changed the jump Z velocity just for that one jump, reset it when you get back, and it can get a little bit messy. This way, all we need to do is we can promote this to another variable. We'll call this air jump velocity, or in fact, I'll call this one air jump force. And now we know that we can change this once, or we'll set this once, and that is the only time we'll need to account for this, because that will be accounted for otherwise in the logic that we'll be using. So this is just one of the other benefits that will come from understanding the logic provided by the Unreal Engine and all of these incredible classes that come with it, but also knowing how to extend them a little bit and add some custom logic and functionality to our classes to work exactly as we want them to. Now, we're going to take a lot of this in a very similar way. We'll be using most of this for our wall slide jump as well. So I'm going to Control W to duplicate this, and I'll plug this straight in up here. Now, we're not going to leave it exactly the same. There will be some changes, namely in the velocity that we'll be applying, especially the force away from the wall, because we want this to not just go upwards, we want this to go away from the wall as well. Mainly because, of course, that is going to be what stops us constantly sliding up the wall. And in most wall jumps, you want them to have some angle away from the wall so you can jump between multiple walls rather than just getting that vertical movement. Now, another thing is that if you had the art assets available, you'd probably want to make a montage specifically for launching away from the wall. But just to show that something's happening, I'm going to reuse the double jump, as this at least will show that some force is being made, and it's better than having no animation. The main changes we'll make, though, is that we won't need to add to the jump count here. I want to be able to jump almost indefinitely between walls, and we're going to do a few extra steps to account for whether or not we've made a double jump in the past when we're doing a wall jump. But the main thing we're going to change is the get velocity. That isn't of concern to us anymore. Instead, we want to find the character's forward vector. So we use the get actor forward vector. We want to multiply this by another float variable. So we use the multiply node. Now, if you're using Unreal Engine 4, that will let you search for a multiply vector by float. So I'd recommend using that. In Unreal Engine 5, that's been taken away from us. What we need to do instead is just plug in a float value here, and that will automatically convert the calculation pin for us. Now, we don't want to actually use the air jump force though. I'm going to duplicate that and I'll rename this one wall jump force. And the reason being is one, that we might want this to be different from the aerial jump force anyway, but also because we're facing in reverse essentially, because we flipped the character, what we want to do, we need to make sure that we invert this. So I can set this to -500 and multiply the value by -500. So we're moving, adding a force 500 units away from the wall to kind of propel ourselves forward based on where we're looking. And then the resulting pin from this can be plugged back into another addition pin down here. And as we've done previously, we're not going to apply anything to the X or the Y, but we will apply a Z value. And in this case, I think we can reuse the air jump force just for the Z part of the calculation here. If we find this isn't strong enough, and if we find we want these to be completely separate from each other, then we'll just come back and we'll replace this with another custom value. So again, we can come in and we can test our new implementation. And this isn't working quite as intended, so we'll take a look at why this might not be happening. So I'll keep this in play here so I can see what's happening in the background and select the player so that I can debug through this. So when we jump, we can see that we're not getting anywhere here. We want to make sure that we're getting that path taken now, and that is working. So we're doing the right type of jump. We know that we're checking into the right thing. It could be that we're not passing in enough value. So let's double this and maybe see if doubling this will make us launch away from the wall. It's because I pulled in the wrong thing here. So we're getting the air jump force. We want the wall jump force. I just didn't replace that, or thought that I did. So maybe the air jump force will be enough here. We need to make sure we're getting this negative value, and this just kind of reinforces why we need the negative, not the positive value there. So we'll go up again, jump away, and there we go. That's more of what you would expect from a wall jump. And that looks pretty good to me. I think that's fine. So from the other wall, we can jump from wall to wall, and that is looking pretty cool. So I'm happy with that. I think that's pretty good. That's essentially what I kind of expected on the first run before we realized that I had the wrong value plugged in. So that is good. Like I said, we might decide that we want some more verticality when we're doing a wall jump, but that is pretty cool for now. Now, the one thing that I like to see in games, and this might be too easy for some games, it might be perfect for others, but what I've done there is I've done a double jump, and that is now capped out the maximum jumps that we can do. What we can do to address this is really consider how we want the jump system to work. Now, I personally like the games where you can almost kind of strategize with it, where when you hit a wall, you'll get an additional jump, specifically an additional air jump when you leave the wall again. So even if you've taken all of your double jumps or your aerial jumps, by doing a wall slide and jumping off, you get one more, so you can get, again, a tiny bit more verticality and that last kind of push away from where you were initially going. And to do this, there's a really, really easy thing we can do. We can make use of the logic we already have on the event graph just here when we know that we've already hit a wall slide. So we can get our max jump count and we can set our current jump count. So this is kind of cheating in a way. It gives us the result that we want. So we can get the maximum jump count, take one away from this. So subtract one from the maximum and set the current jump count to that for as long as we're on a wall slide. So this means that every time that we enter a wall slide, this solves two problems. So now, even if we've done a double jump, this immediately resets the jump count so that we have one left available. And then we can go from wall to wall. And then not only that, but we get one more additional jump at the end, which is what I quite like to get that kind of extra feeling of control over the character. And like I said, this might not work in all games. It might make things too easy, or it might add some flexibility that would ruin the puzzles that you had in mind. And that's fine. If that's the case, then just don't do this bit. So skip this bit. And what you'd want to do is you could do, again, multiple things. So every time that you hit a wall, maybe take one away here so that you could have continual wall jumping as long as it's a wall jump state. but make sure to cap that so that you don't get to reset that and do another double jump afterwards. The other option would not to be do any of this at all, so don't base this on the jumping logic. The very easiest thing would be to reverse some of the checks here. So what you could do is do this branch check first. So if you're in a wall jump, don't even check the number of jumps available. Just go straight into this logic if the jump button is pressed. And I'm not going to go through that just because I think it's easy enough to implement, but it's not the type of functionality that I'm looking for. But that would be another option. Then what you're doing is you're only checking against the jump count versus the maximum jump count for the either ground jump or the aerial jump. And that's something that's going to help us here actually. I'm going to comment around all of these, just so that it becomes very easy at a glance when we come back to see exactly what all of these branching states are leading into. So we can see now that one is going to be specifically checking to see if the result would be a ground jump, the other is checking to see if the result would be an air jump, and the final one checking to see if the final result will lead to a wall jump. And then we know where to update this logic in the future. So hopefully that all made sense. Hopefully that description as well. I've not went into kind of tangents like that. I try to keep that to a minimum, but I appreciate that the approach that I've taken might not be what you're looking for. I can only think of a few different types of wall jump to air jump combinations. And I think that explanation kind of covers all grounds if this isn't quite what you were looking to get done. But I think for me, that is something I quite like. So that additional air jump is pretty cool at the end. And I think that looks pretty cool. We've got the velocities that we want, or at the moment that look good. Again, we'll be updating the gravity and things a bit in the future. So we might come back and replace some of this anyway, specifically the launching variables that we have. The final thing, I don't think this is going to be happening. On some rare cases though, what you might find is when you're sliding down the wall, oh, it does. Okay, so we want to reset this. I thought it would be less likely to happen. So because we are doing the wall slide, and I guess we're technically not entering landing, or if we are, something on the event tick is firing to replace that after the landing reset would have been done, which isn't a problem. So actually I can see what it is. At the moment, we're only resetting it from wall sliding if we jump whilst on a wall. So what we also want to do on the landed, we're just going to do kind of a clean sweep reset of all of the values that we're tracking. So just to double check really that nothing gets missed out like that did. So we want to make sure that when we hit the landed state, we are no longer wall sliding. We can also make sure that we hard reset the jump count. So we need to make sure that that's being tracked as well. And although this shouldn't need to be done, we can also just make sure that this gets called. So calling this one extra function or event isn't going to cause us any issues. So we can find our wall slide velocity reset call, and we'll use that one as well. So when I was sure, we've done this one twice, I didn't notice that. I think what I was actually considering is the gravity check. What we probably want to do is this just here. So we're going to get our gravity scale, and we'll make sure that we also reset the gravity so that we don't have that being missed out either. We obviously don't want to slide off of the wall, forget to reset the gravity, and be running around with a 0.01 gravity or something, because the next time we jump, we'll take off. When we now land, we're going to reset the jump count, the wall slide reset check, and the gravity scale, just so that none of these are missed out on any kind of bizarre use case scenarios. So we can do that, and we're going to get that back normally. We can slide down, and that is all looking perfect. So also remember that if you are wondering where that capsule is coming from, that's just because we have this tracing, so or debugging, so we'll set that back to none. So I think we're pretty much done with that now. So we can jump and we won't get that debug trace, and that is looking perfectly fine. We can tidy this up, but we will probably make a few more improvement passes to this in the kind of final polish stage. So we'll leave this for now. What I think we can do is, we know that this is completely to do with jumping. So we'll come back in here. We'll grab all of these nodes, shift select all of these nodes, and we'll drop this down into a function, and we'll call this one jump check. I think what we're doing here is we're not just jumping, quite specifically, we're checking what to do with the jump input. So just because the player's pressed jump, we're going to check whether we can jump. If we can, what type of jump. So I think that name kind of makes sense for the functionality being housed in there. That is pretty much it. So I think with all of that done, they are the main mechanics. I haven't noticed during these kind of brief demonstrations here that anything isn't working. So that seems to be the bulk of the main mechanics working. There's one thing that does stick out to me a little bit, and that is that there's especially when we're going up, I can see why that's going to be. There's a brief moment before we get this rotation being applied. And that is because we're not doing this until we have confirmed we're in a wall slide, and until we've also confirmed that the velocity has been set to 0. So even if we're in a wall slide, if the velocity isn't 0, we're not doing this. So we're going to fix this as well. I think that might be under the polish pass because it's not really stopping anything from working. But it doesn't look great because you've got, yeah, it's kind of a snap that feels like it comes a little bit too late. So we'll keep that in mind, but I think we'll keep this very topical. We've just done our jump mechanics improvement, and we'll come to the other issues in their own topics. We're going to take a minute and just go through some of those class improvements. And in fact, building up on what we're talking about earlier, as well as looking at how we can fix the wall slide, I think in fact we will do what I mentioned, whilst I'm still going to keep the general wall jump how I wanted it, which is that we have the jump from a wall followed by an additional air jump if the player chooses. Looking at the way that this is working, because we're resetting this anyway, this actually doesn't have anything to do with our jump count. So there's no reason for this to be after the bulk of logic that is checking for that. And in fact, if I were to have written this in C++, I think I would have just automatically done this first to check if we're in a wall jump and kind of got that bit of logic out of the way. So I'm going to cut this, making sure that we don't get confused now with what we have here. So really all we're doing is we're saying that if we're falling, then we're going to do the air jump. If we're not falling, we're going to do the ground jump. We can unhook this. And this is one of those things, it's always good to try and keep the code as tidy as possible, whether that be in C++ or Blueprint. It's going to make managing it much easier for us. We can move that here. So these are our conditions for the type of jump we're going to do based on whether we're grounded or in the air and not touching anything at all, apart from the ground if you're grounded, I suppose. Then we've just said as well that these are not conditional to the current state of our jump count tally, so we're not going to need to account for those. So we're going to hook this up just ahead. So we'll instead do this first of all. So the first check we'll do is whether or not we are in a wall jump state, and we'll move this across. We could probably chuck this into its own function if we wanted to, but I think it's going to be nice to have everything clearly in one place. So again, if we wanted to come in, quickly change something, because this is housed away in a function already, we don't really need to house a function within a function to keep things tidy. We will only be in this function if we ever wanted to update one of the different states of jumping that we have. So just a quick consideration I made there, but I think my final choice is that we're just going to drop it down this way. So we're going to come in, we'll check. The first thing we'll check now is whether we are in a wall slide. If we are, because we're not concerned about our jump count, we're just going to let the player jump. And if we're not, then we'll do our conditional check, and then we'll go through all of this. So nothing's going to change, it's just a different way of reading it. And this means that if you wanted to avoid the setup that I have here, then it's going to make it much easier for you to avoid that additional wall jump setup. And you'll need to do kind of less rejigging yourself. So that's just one quick change, and we'll improve the code that way a little bit. Like I've mentioned, for my setup, I'm still going to go with this approach that I'm going to give it one less than the maximum jump count. Obviously, if we just set this to 0, just in case you're wondering why we didn't do that, that would essentially mean that you could do something possibly even a little bit too easy in this case. So you could double jump onto a wall, rebound off of the walls, and then do another double jump, adding all of that extra velocity. And that just looks a little bit too lenient. So we're just going to get what the maximum jump count is, take one away, and add that to set that to be our current jump count. And then there were going to be some things here that we want to fix as well. So we only want to do this if falling. I think all of this is okay. We want to make sure, so this is too long. We don't really want all of this going on. We could probably promote this to a variable. We could even make this a function again. I think what we can do with this is we will promote this to a variable. It's not going to be extra expensive or provide an impact that we can't deal with to take the whole vector. And again, if we expand upon this, we might want information about the whole vector a little bit later. So we can store this now. That means we don't need this to be dragged all the way along here. So this will just help us tidy things up and let us choose where we place this. We're going to get our out hit normal, which we could probably rename to wall hit normal, because we might have a lot more kind of functionality in the project, which is going to be checking normal values. So this one's specific to our wall slide. We wanted the normal Z there, so we can just take this and kind of combine these together. I think the really important thing is we want to do this as soon as we hit our wall slide status. So not after the branch here, but as soon as we enter our wall slide. So we're going to need to move all of this along a little bit. And then I'll just paste this here. So as soon as we come in, we will change the jump count. And before we even do the velocity check, we want to make sure that we snap the character to rotate around. So this should just look a little bit more responsive. So we can check that straight away actually, and just see if there's anything else we need to do here. And I just realized there, it wasn't so we had a bit of a problem. You can see what was happening just before I fix it. You can see that on one wall, we're not rotating. On the other one, we are. I wasn't taking the wall hit normal directly. We were getting the rotation, I think it's rotation from X. And of course, we need that from the vector, not the Z. So I keep trying to home in on the Z there. So rotation from X vector. That's what we were using. And then we're going to split this one. So I just seem to have gotten rid of some of the old logic when I was moving things around, trying to tidy that up. So we'll plug that in to our check here. And that should now work the same way. We just want to move a few things out of the way. We could probably move all of this up a little bit. It's a bit unfortunate that because we need this reset, it's not very easy, or we can't do a do once inside of a function. So it would be nice to collapse all of this into a function. But I think in this case, we can probably leave this where it is. That would be perfectly fine. That should now work as it was previously. Just forgot that I'd replaced the wrong thing there. And yeah, that looks much snappier now. So that just feels a lot more responsive that as soon as we hit the wall, regardless of whether we have some vertical movement going on, so some positive Z velocity, we're immediately flipping, which means we get a much more responsive wall jump setup. So that's better. I'm happy with that. You could if you wanted. I'm not a huge fan of this, but if you wanted this to be its own thing, but still work with a do once, you could collapse the nodes, which gives you this. And I think in this case, actually, because we don't have that flexibility, we'll call this one the wall jump check or wall slide check. On these, if you're not aware, you can provide an execution pin. So we can change this from a variable to an execution pin. We'd call this one, I guess, return or something, just in case you wanted to drive more logic from this. Like I said, normally I'm not a huge fan of these. I don't use them very much in my code. Maybe in rare cases like this, where it's going to be quite important that we have this do once for this kind of additional step of making the wall slide feel nice. Otherwise, I wouldn't be too worried about putting this into a function, but we do want to make sure that we can reset this just to get that initial kind of snappy, sticky feeling to the wall. And I think overall, they are the updates and the checks that we wanted to add just to make our mechanics feel better. So that is the logic that we're kind of directly responsible for, implemented and improved, which leaves us with just a general overall feel of our character, utilizing the character movement component, getting the most out of the character class, and really making this feel like our own. Because at the moment, we haven't actually changed very much from what you'd see in the default third-person template. And that was the whole idea of this, is that we're looking to see how we can make this our own project, how we can really make this stand out. So that's what we'll be doing in the next topic. We'll be looking at how to change some of the variables, what we have available, and how to make those feel better. Inside of our character movement component then, the thing that I've mentioned a few times is the gravity scale. So let's start by adding the improvements to our character with the gravity scale. At the moment, if we jump up, it feels like we're in the air for quite a while. It feels a little bit floaty, and we're going to need to do something about this jump as well, because if we're coming down from a jump and we try to do a double jump, we're not getting enough force to propel us back upwards. even though we've told it to override the Z velocity, there's going to be an additional thing here we want to do to make sure that we get that implemented. So whilst we're here, why don't we do that now? So in an air jump, before we apply our launch of the character here, this is going to be important to test the final kind of results of how this feels. What we want to do is we're just going to cancel out the velocity that we have, as well as accounting for that. We're just going to do a quick reset as well. So we'll get the character movement component again, as we've done in the past, and we're going to set the velocity. So again, you've seen this before. We want to not just set everything here. We want to make sure that if we're moving, we don't want them to kind of stop on the X or the Y, but we do want them to stop going up because that's where we're going to account for this new velocity we're passing in here. So we're going to do a very similar thing here. We're going to get the current velocity as well. We'll break this into a vector because, of course, we only want 2 of the different float pins here, and we're going to make a vector from this. We'll plug this make vector just here, and we'll plug in the X and the Y, and we're going to zero out the Z. So this is going to make a new vector for us with the Z being set to 0. So when we do this jump now, the Z velocity will be zeroed out if we do a double jump, but the X and Y will not, which means we can get that much nicer launch, even if we're on a kind of downward arc in our initial jump. So that's really all that's doing there. We probably could do with something fairly similar for the wall jump, although it doesn't feel too bad, but you do have the option to reuse that if you wanted to, just here to reset the velocity as well. So I think because that could be a little bit of a utility function, why don't we grab all of these? We'll collapse this to a function, call this one reset jump velocity. This we can just plug in between these. That will do its quick calculation, and then we can apply our Z force here. And we'll just do the same thing here. So we're just going to call that new function. Because I think although it's hard to find a state where that doesn't feel great, without that being there, I think we will jump into a use case where it's going to help to have that zeroed back out. If we start picking up a lot of downwards force and we still want to have you always want to provide the player with a feedback loop that they understand. So you don't want them to try and plan based on a velocity they've seen 100 times before. And then that 101st time you apply half the velocity because you haven't accounted for something and they miss a jump. It will make them feel as though they've been cheated. So we just do things like this so that they always know exactly what to expect in certain scenarios. So that's what we're doing here. That's going to improve that. So with that accounted for, on the character movement component, we're going to set the gravity scale to something around about 3 or 4 times. I think if we look at games like Mario, I think I remember reading an article describing how that actually in certain cases uses 8 times gravity, because what we're applying here is a gravity scale multiplied by our project defaults. And if we look for what that is, if you're not familiar, we have a default gravity of minus 980, so essentially real life gravity. And that just feels a little bit odd. Because of the amount of force we're applying upwards, it makes everything feel, like I've mentioned, too floaty essentially. So what we have now is we're going to fake the gravity that we have by a 4. And we're now really not making any distance. So we're going to need to come in and account for other things. The first of which will be the jump Z velocity. So we've multiplied this by 4. We probably don't want to multiply this value by 4. We can try that if you wanted. So you can just, if you weren't aware, you can type multiplied by or add a sum into this box and it will calculate that for you. So the exact multiplication would be 1680. And I think that's too high. So although we're multiplying gravity by 4, we don't necessarily want to do that here. I think a value around about 1200 might feel quite good. That still feels a little bit too forceful, I suppose. So maybe 900. And then the other thing is our air jump now doesn't have enough force at all to account for this new gravity. So what we want to do is come back into the air jump force again while we've promoted this to a variable and maybe make this one 1200. So we get a little bit extra velocity in the air. There we go. And that is feeling, so the character just feels much faster to control. We also want to apply some extra force on the wall jumps because again, that wasn't feeling as though we were getting very high. That feels as though it's going to take quite a while to jump up the walls. So this will be one of those points now where you really want to just come in and play around with the different values that you have until you find a kind of setup that makes your character feel good for the type of game that you'll be using them in. So I'm quite happy with the jump force here. I think the gravity scale of 4 is working pretty well. The way that we're applying the wall slide and the wall jump has ended up being a bit of a problem. So I think for the air force, that feels around about fine, the jump air force that we're applying. And I think the forward velocity from the wall at 500 actually worked out quite well. But I think we want maybe more of an arc going up. So we're going to unhook this. We won't be using this one for our wall jump. What I'll do is we'll say maybe something really high needs to be used here, like 1800. We'll promote this to another variable, and we'll call this one wall jump vertical force. So just to make that slightly different from the other wall jump force we have here, we could probably even rename that one to forward force. Okay, so we're going to need to start breaking down a few little things here. We're doing a lot of our own kind of custom logic now. And there we go. So maybe that's actually too high now. But again, this is part of what it comes down to, is just tweaking numbers and getting that good feeling system. So I don't want them to essentially climb an entire wall in 2 jumps. 3 or 4 jumps feels a bit better there. And what we can get is maybe a nice bit of an arc. So one thing I'm kind of aiming for is where you can loop back on yourself a little bit. So you could potentially clear a wall jump just from one side. So if we had a wall like this, what I'd want to do is be able to loop back around. And again, all of this can be achieved through the character movement component. So the next thing we're going to look at is the aerial control that we have. One thing that I've kind of skipped up to this point is the acceleration. So if you wanted to play around with the movement speed, I think for my project at least, I hit on a pretty sweet spot with the movement early on, so I haven't really thought about it too much. But we have the movement is at the moment based on this acceleration speed. So the easiest way to demonstrate this, if I set this down to something really small, we can see that it takes a very long time to get the character moving up to speed. And we're adding a very gradual acceleration to this maximum sprinting speed that we have. So if you wanted to play around with that to get that kind of movement system more like Sonic compared to Mario, I think Mario has a very kind of instant, almost hits maximum speed pretty much straight away, whereas Sonic goes through the walk to the jog to the run to the like full-blown Sonic sprint. Then you can play around with the acceleration to kind of mimic that as well. I think for this, again, I quite like that instant acceleration being quite high. Braking force, again, we don't want this feeling too floaty or slidey, so we pretty much come to a stop as soon as we release the key, which again gives the player that kind of immediate feedback that it feels as though as soon as they press something, something's happening, and as soon as they release something, again, their input is received. So that brings us back to our jumping functionality. So we're going to go down to jumping. We can see that the air control here is a value that we have available to us, and this is set to a very, very low value, which means we have very little air control. So when we're in the air, we're kind of stuck on the trajectory that we were given when we were moving. So based on the velocity that we started moving when we're in the air. If we hover over this, we'll see that it should give us a tooltip showing that 0 is no control, 1 is full control. So if we wanted to really have a lot of control over our direction in the air, we're going to set this to 1. So now if I start jumping when I'm moving to the right, I should be able to turn around and get some movement back to the left. So we should be able to use this now on the wall slide. And you can see we can use this single wall, which we couldn't do earlier. We can jump straight forward if we wanted to, but we can now kind of loop back round and make our way scaling up just one side of the wall. So another way that we can just tweak some variables and we can get some completely different kind of mechanics or functionality into our character. So I think with just these, we have a pretty good character kind of setup or controller going. You can play around with other things. You've got things like the ground friction. You can always change this at runtime as well. So if you wanted to change this to account for things like a more slippery surface, you can change the ground friction. You've also got things like the aerial control boost multipliers and things, and you can hover over all of these to get more information. And again, I would really recommend just setting some time away. You can see just how much the character controller offers. Now that we've seen the bulk of what we can use, the general ways that we can kind of apply these, you can then come back in and just start playing around with these values and seeing what they do, change them, make them an extreme, see how they work, and if they'll improve your character setup. Just a couple of other things before closing out with the movement improvements. My character's feeling pretty close to what I want this to be. We've got the rotation rate being controlled by the orient rotation to movement. We might want this to be a little bit responsive, a little bit more responsive. So I'll just set this to exactly double. This just means how fast when we're turning like this, does it snap around to look the other way. If we set this really low, then when we're turning, you can see, well, it's not turning. I've got to really hold this down for it to do any rotation. So that just speeds up or slows down the rotation. This is useful to know because some people will want to know why it takes so long to turn like this. So if you're just going in one direction, you can see it takes a little while. The other side to this is that some people might set it too high, or you might be in a project where it's set too high. And then you get this kind of snap. You can see there's like a visual blur because it's snapping so fast, and you may not want that. So this is where you can kind of hone those values in as well. I think 720, you can see that it takes a little bit of a click, but that looks pretty smooth for a almost turn on the spot type thing. So again, that looks pretty cool. Looks a bit better than the 360. So I'm going to use that. And I think we're pretty much good. I think this is, I would be happy with this as a character controller. Like I've said, it's not exactly Mario, but it's much closer to an interesting third-person platformer character controller than I've seen in some of the videos claiming to have remade that type of project. So, as I mentioned, this wasn't ever intended to be an exact recreation, but I wanted to show you a really more in-depth use of the default character controller, what it provides, the character movement component, what it provides, and how you can really add some flexibility by adding some of our custom logic like we've done here, whilst using a lot of the built-in functionality as well. One other thing did just pop to mind before we do completely wrap this up, and that is the thing that I mentioned a while ago, which is on the spring arm component we have to do with adding the camera lag to our character. So we've already added this on. So we do have some camera lag when we're moving. You can see that if I move sideways, it takes a little while, a very like split second, to catch up with our character. Alternatively, if we took this off, it's going to feel very snappy. It doesn't feel very dynamic. It doesn't feel a whole lot different there, in fact. So if we put this back on and change the value, so you can see here it says lower values are slower, so there's more lag. So if we set this to something really low, then we're really going to see what this does. So we really have to kind of move almost out of frame before this starts following us. And that feels like a very much more kind of cartoony or dynamic camera. So this can feel quite interesting just for different game setups. But on top of that, it also means that you don't get that snappiness like we saw with the crouching movement. So we can add some lag to the camera movement, and you can, again, really play around with this to tweak this to your kind of desired game feel for whether you want this to be very responsive and almost locked on the camera, or for it to have that very small delay. I like the kind of more exaggerated delay for this character. So we need to get a little bit out of frame before it really catches up, but we can't quite jump out of frame even vertically when we're doing like wall jumps or something. So I think 3 is pretty good there. And we can also add some camera rotational lag. The name pretty much indicates what that is. So when the camera's rotating, there's going to be a small delay before it catches up with us again. Now this type of thing you can't see too much here. It just feels as though, if anything, that the camera's a little bit gummy. It feels as though it just doesn't quite respond to what you're doing, especially on the lower values. This works a little bit more. You could kind of fake some camera movement in first person, or maybe a more kind of top-down RTS style thing might use a little bit of rotational lag. I think for this, if we are going to use it, it's going to be a very subtle feeling, so the higher value that it defaults to. But in fact, I think for this type of setup, I probably wouldn't use the rotational lag. I think the lag from the player movement is pretty much adding that extra kind of flair to the game, as well as my graphics card is adding some flair there as well. So that is pretty much the whole setup. Yeah, I think that was the only other thing I wanted to cover. Just those kind of final finishing, the extra polish that we can add to the project, just using a collection of components that we already had readily available on our character. For the real final touches to the project, outside of the actual movements, I think we've got a really good controller setup here. Just a few other things that we can do to make the very simple level that we have look that little bit better. One thing I've done off screen in between recording is I have set the light system to be a static light, and I've built the lighting. That was just a requirement because my engine was really struggling to run anything in Unreal Engine 5 at runtime. And that does give us a slightly more kind of clean look when we're in game, and we can see hopefully that the FPS is staying a little bit higher. I'm just going to hide that. We don't really want that to be displayed. So that would be the first thing. We have a built light system, so I've already built the lighting, and this is the final result. I think on top of this, if we wanted to add a little bit extra, we could come to the create option, and in Unreal Engine 4, that will be in the options on the left-hand side. You can search for the post-process volume if you can't find it. In Unreal Engine 5, it's going to be just here, the visual effects, post-process volume, and we'll just drop this in. This will be the same in both versions. You may have a few extra options here, I'm not 100% sure. But what we can do is we first want to scroll down and make sure that this affects the entire map by finding the infinite extent unbound. So this will affect everything, not just where your camera is. We can put this anywhere, maybe off to the side so it's not in the way. That will, like I've said, affect the entire map. So we can start adding some effects now. Now, the general ones that you'll see, maybe a little bit of bloom, people tend to find make the map look a little bit nicer. We can really blow this out though, so you don't want to go too high on the bloom. But again, this just kind of shows that this is affecting everything regardless of where we are. Another popular one is a little bit of chromatic aberration. So this will add those different colors kind of going around the outside of different objects. I'm not a huge fan of that one. So we're just going to turn this one off. We can also look down to things like our image effects. Now, another nice one, just adding a vignette around the outside. So this is like a encroachment of dark color from the outer ring to the inner, and we can come in and see what this starts looking like when we throw these together. So this can go quite well with bloom. You can get a little bit of bloom in the middle of the screen and then kill that around the outside so it's not too overpowering with some vignette around the outside. So that is one option we have here. I think the intensity seems to have been reset on mine, and the vignette you probably don't want to take up the whole screen like that. But again, it just adds some extra noise and detail to the camera. This is what kind of makes the game feel as though it's had a proper kind of artistic pass, and I'm definitely not going to do this any justice. Generally, adding extra noise to your game can make it look more realistic. You don't get like perfectly clean, unfiltered camera shots or just general views of the world. So adding things like grain jitter, increasing the size of the grain. Again, you don't want this to be too noisy, but this can be an effect if you wanted to. But just adding subtle effects that people might not quite see that are there, but when you look around, you can see that it's not perfectly pristine because, again, nothing is. And adding a little bit of noise like this through a post-process volume can just really kind of wrap up your project and make it feel as good as possible. You can play around with depth of field, a little bit harder to get working, so anything above double digits or below double digits, you get really big extremes, so it can be quite hard to work with. Again, ignore these, this is my GPU. So I think around about 50, you can see some fairly decent effects, and this is one of those where you might want to come in, press simulate, in fact, press play in the normal viewport mode, press F8, so you depossess your character, come down to the post-processing volume, and we can play around with the depth of field so we can see what 10 would look like compared to something like 80 or 50, and you can start getting an idea of what you might want this to look like when you're a little bit closer to the character and how this can kind of affect your overall result. So this is a nice way to test things as well. You can get an idea of what it would look like in-game by pressing play and playing around with the post-processing volume here. So then you've got other things as well, like the film, different color gradings, which again, I definitely wouldn't be able to do any justice. I'm going to leave these, but you can add different saturation, different colors to your shadows and different color balances and things to kind of set the mood in certain scenes. Updating the reflections more for the lumen or global illumination side of things. Another one which can really make a difference. I don't think this takes full effect in Unreal Engine 5 because of the lumen, but in Unreal Engine 4 you can get some good results with the ambient occlusion, adding some extra shadow detail around the darker crevices that you'd see down here. You can see it doesn't take any effect here, but it's worth trying if you're in Unreal Engine 4. And then things like motion blur if you wanted to add that as well. But I think for the most part, these will just be like a few small changes that I'd make. The more that I've changed, the more that I've noticed the vignette's gone away. So I might go back to the image effects and just increase the vignette a little bit. We can press F8 again and see what this is like to control. So we've just got a little bit more noise, maybe too much noise in the grain jitter. So we could perhaps turn this down and turn the size down a bit so we get things looking a little bit grainy, but not too much. And we get some kind of interesting results here. So it just immediately makes things look a bit smoother without really doing anything to the actual assets. And everything just looks a little bit more kind of not realistic, but believable in that they're not just perfectly clean slates of color kind of populating the world. So of course, all of that was done during runtime, which means you will need to remember what you were changing and just come back in and make those very slight changes. So I think I changed some of the image effects. If you wanted to, when you're in runtime, you can always come in and copy the values that you want to store. Just remember which ones are most important and copy those across. But again, that is quite a nice way to just test what it looks like in gameplay. I think the other one I added was a little bit of depth of field, wasn't it? So you can make changes like this and then add those to your final project just to get things looking like it's had a little bit more attention given to it. Hopefully you've enjoyed that content. And as always, I just wanted to say a big thank you to all of the people supporting all of the work that I do here on YouTube, allowing me to keep making this weekly content. So a big thank you to all of the names scrolling down the screen.